now, everything's okay. No matter where you find yourself, no matter what kind of stuff is going on in your life, underneath it all, everything's actually all right. You're okay. You have more power than you might be giving yourself credit for. And if you have something that's going on in your life right now that's challenging or painful, it's just a reminder to take a little bit better care of yourself. Because you're worth it. You can have this feeling anytime you choose. stuff is going on in your life, underneath it all, everything's actually all right. You're okay. You have more power than you like to give yourself credit for. And if you have something that's going on in your life right now that's challenging, painful, it's just a reminder to take a little bit better care of yourself. Because you're worth it. You can have this feeling anytime you choose.
live. Good morning, afternoon, and evening, depending on where you're joining us from. I'm excited to welcome you to Prisma Day. This is our second annual Prisma conference and the first to go online due to the corona pandemic. Prisma Day is a community-focused conference bringing together developers, industry leaders, and community contributors. So on one hand, we're really happy to be able to break the geographical barriers and reach so many of you worldwide. On the other hand, I think we all miss the opportunity to get together in the real world and celebrate the sense of community that we're building together. So before we get started, I want to thank you for joining us today. Can only imagine the work and family life that you're balancing right now through this difficult period. I'd also like to thank our speakers for taking the time to prepare and share their knowledge and experience and adapt into the online format. I'm Daniel, a developer advocate at Prisma, and I'll be your host today. In the last decade, two notable trends have reshaped the way that we build web applications. First, web development went through reinvention cycles every couple of years, from the LAMP stack to SPAs to BWAs to mean stack, and I'll stop at Jamstack just to avoid a stack overflow. Second, in contrast to the first trend, we saw some tools and technologies establish their reliability and adaptability over time. Some examples include the HTTP protocol, the Linux kernel, PostgreSQL, and the SQL standard. This begs the question of what can we expect from the future of application development? In the words of the Turing Award winner and the creator of TCP, Bob Kahn, you can't gaze at a crystal ball and see the future. What the internet is going to be is in the future is what society makes of it. Prisma Day is structured in the spirit of those two trends, preservation and reinvention. On one hand, preserving the established wisdom of things like relational data and type safety. On the other, showcasing the power of modern libraries and frameworks and the novel deployment models that serverless computing and containers allow. I hope that today will give you a glimpse into the thriving Prisma community and inspire you to learn more about modern application development, databases, and the Prisma ecosystem. In an effort to avoid technical difficulties, we've pre-recorded the talks so that you can get all of the content without glitches. However, I'm live and the Q&As will be live. The speakers will be hanging out on Slack, on the Prisma Day channel. For shorter talks without a Q&A, you can submit your questions directly to the speakers in the Slack channel. You'll also be able to identify the speakers, have a little green label below their name, below their picture. And obviously, we know that an online event doesn't compare to an in-person event, but we'd still like to try hard and hear from you during the event. So if you haven't already, I invite you to join our Slack. You can find the link just above me, slack.prisma.io, where you'll be able to engage with speakers, get real-time information, and meet the other attendees. Also, keep an eye out for the polls that will be running throughout the day during the breaks. There'll be QR codes on the break screens. And we also have Prisma Day speakers. You can see one on my shirt, and we have many more. You'll be able to get them, and we'll share the link via Slack so that you can sign up and we'll mail that to you. And please, please, please share a snapshot of your sweet home conference setup and tag it with the hashtag Prisma Day on Twitter. We'd love to see where you're watching it from. Lastly, I want to ask you to take a look at the code of conduct, which can be found at the footer of the Prisma Day website. It's part of our attempt to make this an inclusive and comfortable environment for everyone involved. Now, let's get started. I'm absolutely delighted to invite Zern. Zern is the co-founder of Prisma and a longtime database geek. His work has been very instrumental to Prisma's architecture and focus on developer experience. So now, without any further delay, I bring you Zern.
Welcome to Prisma Day 2020. I'm the co-founder of Prisma and incredibly excited to have you all here today. Earlier this month, we launched the GA release of Prisma Client. So I would like to start by talking about the principles that guide us in our design of Prisma Client. First of all, with Prisma Client, we set out with one clear goal in mind: create a database access library that has significantly better developer economics than anything that exists today. For us, that meant leveraging recent improvements in the TypeScript compiler to provide automatic type safety and auto-completion for any database query without manual setup. With Prisma Client, there is no need for manual typing out classes to match a database table, configure mapping with XML, JSON, or anything like that. The CLI will generate a fully functional type-safe data access library by introspecting the database. And in contrast to the existing query builders, Prisma Client provides complete type coverage for all input and output from your database query. No magic string concatenation is needed. And the result is a very intuitive experience where your editor guides you to do the right thing instead of you having to look up specific syntax on Stack Overflow all the time, like I used to do. If you haven't used Prisma Client already, you'll have plenty of opportunity to see this during the talks today. But I'll also encourage you to jump right in and give Prisma Client a try. If you have a MySQL or Postgres database, then you can be writing your first query in less than 5 minutes. And now, I know that 10x is kind of a cliche, but I think it's fair to say that we have achieved our goal of being 10 times better in developer economics. And the 10,000 plus developers who use the Prisma CLI every week is proof of that. Now, having a library that is nice to use is not enough. With the GA release, we covered a lot of groundwork, paving the way for the many features you all have requested on GitHub. We have hired some great product people from Zero and Contentful to help us ramp up the work and quickly get to a broad set of features. The foundations are in place, so we will be rolling out new and exciting features every month for the foreseeable future. If you want to stay up to date, you can check out our blog regularly or simply follow us on Twitter. Or if you're even more engaged, jump over to GitHub and help out by providing more context to all of our feature requests. When adopting a technology, it is important to evaluate the health of the ecosystem. You want to pick a technology that is trending up, a community that is friendly and growing every day. Instead of adopting a mature technology in decline, you want to pick a technology that will see its heydays in the decade to come. Some of you have asked us, how will Prisma make money? How do I know that Prisma is the right technology to bet on? How is this even viable? So let's talk about the Prisma strategy, why we are doing what we are doing, and what you can expect from us in the years to come. Prisma Client is free and open source. We believe it is the best data access library for JavaScript and TypeScript developers, and we want as many developers as possible to benefit from it. Some of you are individual developers, hobbyists, are working in early stage companies. You'll probably never pay money for a Prisma product, and that's totally fine. But many of you work in companies, startups, enterprises, consultancies, and many of you are spending countless hours solving problems that don't, strictly speaking, fall within the set of responsibilities for a data access library, but are nonetheless related somehow. Examples include deploying a complex schema migration without downtime, or implementing caching in the applications to reduce load on the database, or sketching on a whiteboard with a coworker to decide the proper database schema for a new feature, or trawling through logs to understand why a certain part of the application is getting slower, and on and on and on. So why doesn't existing data access libraries help you with all of these things? Is it simply a lack of imagination? No, of course not. It's just outside the scope of what these libraries are trying to do. But luckily, we are more ambitious than that. From the beginning, we have designed Prisma with the expansive vision in mind. The Prisma schema file, for example, is great for taking a quick look at the database design, but more importantly, the declarative definition enables collaboration in teams that span multiple language ecosystems. The Rust query engine enables us to be more performant than a pure JavaScript implementation. But more importantly, it enables us to build additional products in the future that help teams work effectively with data. So there you have it, the Prisma strategy. And now I'm happy to share something exciting with you. We're working with some of the smartest people in the industry. Our investors are also investors in and on the board of amazing companies like Netlify, Gatsby, CockroachDB, and many other dev tool companies you all know and admire. So today, I'm proud to announce that we are adding an additional set of very smart, talented people to our little world. We are announcing a 12 million funding round led by Amplify partners that will enable us to accelerate our investment in the core open source tools. And with that, I hope you will enjoy the rest of the conference and have a wonderful day.
Thank you so much for the concise keynote, Zoran. Exciting times ahead for Prisma. We'll now do a Q&A whenever you're ready.
I'm ready for questions and answers for sure.
Great. So I think the first question that is coming up is, when is Prisma Migrate coming?
That's a great question. With Prisma Migrate, we wanted to do something a little bit different. So Prisma is here to make working with databases easy. So of course, we need a solution for migrating your database. But there are already a number of solutions out there for migrating databases. And they work fine. We want to build something that not just works, but is also a delight to use. So if you have used the experimental version of Prisma Migrate already, or maybe Prisma 1, you'll know how our declarative migration system is actually really nice to use. And we want to build on that and create a system that is really nice to use, but also scales to really big production environments. So you'll see the first results of that later this year.
Thank you for that. Another question that's coming up is, I think this question comes up quite often, is how is Prisma different to ORMs like Sequelize and Type ORM?
That's a great question. So I already touched on this a little bit, that we strive for delivering a much better developer experience. A generated client tailored to your specific database is just fundamentally a much better experience. You get full code completion, and the editor kind of guides you through developing your app instead of you having to look up in documentation or just see what happens when you run the code. So better developer experience is a fundamental aspect of Prisma. But maybe more importantly, Prisma is a very ambitious project. We spent the last couple of years visiting companies like Stripe and Facebook and really learning from how their application engineers are productive and building big scale applications. And we took that into account when we were building Prisma. So the architecture of Prisma is prepared for a future where we are slowly building more and more of these features that application engineers at big tech companies rely on for their productivity every day. We start with a simple data access library, but slowly we'll see more and more of these things roll out. I'm really excited to talk more about that in a year's time.
Great. Yeah. I mean, I think we're seeing a lot of new things happening in the ecosystem, but it's especially exciting with some of the developments that are happening even within the Prisma ecosystem. Let's see if we have any more questions coming in from the crowd. Okay, I'm looking here. Do we
just get it started?
Okay, so we have a question. How will Prisma make money?
Oh, that's also a very good question. And it's a question you could ask of many open source companies, right? Many of you are using Gatsby, for example, and a few years ago, people would ask, how does Gatsby make money? Eventually, they build a commercial service that complements the open source project. And we are going to go and do some of the same. As I mentioned before, we have this architecture in place that enable us to deliver some really interesting and pretty advanced features without you having to change your application much. And some of these we'll be able to deliver in a commercial setting. We're already working with some companies figuring out what they would really value, what would make a difference for them. It'll be a while before we're ready to really talk about this, but that's what you should be looking for.
Yeah, some of the best things take time. Do you think a lot of those features will be targeted at larger teams?
I think we will see some features that are interesting for individual developers. But as you know, developers are a challenging audience because they can build all the things themselves. So the way to make real money that can sustain a company is to build something for large companies, for enterprises.
Yes, sorry.
It's too early for us to say how the split is between those two.
And if you can perhaps maybe chime in on the question of long-running transaction support. We have a question coming in.
So long-running transactions are interesting. Transaction is a thing you use to group multiple actions together, such that from your perspective as a developer, it looks like you're the only user of the database. And sometimes you want to maybe read some data, look at that data in the code, then take some other actions. And this is what we call a long-running transaction, because it spans multiple network requests. Prisma doesn't support this, and I don't think we ever will. This is a pattern that was really common in the past when you had a big database in a big application. But as you're creating scalable services that run on Lambda, for example, it's really not the best way to do most things. And we will be writing a lot of content about how to take those problems you would usually solve with a long-running transaction and solve them in a slightly different way.
Mm-hmm. Well, thank you so much for the Q&A and for your insightful talk. Hope to see you soon.
Thank you, and hope you all enjoy the day very much.
Goodbye. Okay, I would like to now introduce Nicholas Burke. Some of you may know Nicholas from his extensive educational work in the ecosystem, pioneering projects like How to GraphQL and many more. Nicholas has been with Prisma since the very early days. And before he started at Prisma, he was working as an instructor at Make School Product College in San Francisco. Nicholas is passionate about learning, teaching, and helping other developers. At Prisma, he's leading the developer success team and makes sure that developers can reach their goals with the Prisma tools. Fun fact about Nico, during his very first visit to the office, he spilled 2 liters of water on a table with 4 laptops on it. Luckily, no laptops were broken and he was hired shortly after. So if you're in the currently warm Northern Hemisphere, be sure to keep the water away from your laptop. So Nico's talk title is Prisma Productivity and Confidence for Your Database. And now, without any further delay, I give it up to Nico.
Hello and welcome everybody to my session about Prisma 2 that's titled Confidence and Productivity for Your Database. Let's jump right in. So my name is Nicholas Burke. I'm based in Berlin and I lead the developer success team here at Prisma. And you can follow me on Twitter and on GitHub as @NicholasBurke. The agenda and the things that I want to talk about today are 3 points in particular. The first is an introduction where I'm going to talk about the broad problem that Prisma is trying to solve and then how we want to solve it. In the second section of the talk, I'll talk a little bit about what Prisma 2 actually is and how it works. And then the meat of this talk is going to be a live demo where I'm going to show you how to get started with Prisma 2 pretty much from scratch and build a REST API and a GraphQL API, and all of that in the next 25 minutes. So buckle up for this talk. And let's start with the introduction and the problem statement, that is that working with databases in Node.js can be really difficult. And to understand the kind of options that you have as a developer when you're working with a database in Node.js, I've prepared this slide here. There are basically 3 categories of tools that you can choose from. And the first category is that you can send plain SQL strings to your database with just some relational database driver, basically. And then you're constructing your database queries as strings and you're sending them over to the database. And that's really the lowest level of abstraction. And that can get a little bit tedious and cumbersome to work with these SQL strings and code. You get no type safety and almost no help from your editor when you're taking this approach. The second option then is SQL query builders. And these are libraries that let you compose your SQL queries programmatically. So they give you a programmatic they give you a programmatic API to construct your SQL queries and then send them over to the database. So you are already climbing up a little bit the abstraction ladder, but you're still on a very low level because you're still writing SQL ultimately. And then you have the third category of tools, and these are called object relational mappers. And these tools, they work in a way that you define your tables, the tables that you have in your database, as classes in the programming language that you're using. And there is a problem with this approach that's called the object relational impedance mismatch. And that's just a fundamental mismatch of the way how data is represented in relational databases and object-oriented languages. But this talk today is not really about these three different categories of tools. In fact, if you want to learn more about those, I would recommend to check out this talk by my blog post by my colleague Justin, who wrote about these three different approaches and the trade-offs that come with them. So the solution to this problem is that Prisma makes working with databases easy. And we'll learn in this talk how exactly that works. So the second section is about Prisma 2 itself. Let's dive right in and understand what Prisma 2 even is. But I want to start this section with a short preface, because there is a lot of confusion about the differences between Prisma 1 and Prisma 2. And at this point, if you've heard anything about Prisma 1 in the past, I really want you to forget everything that you knew about Prisma before and start looking at Prisma 2 with a completely fresh mind. So I think we can do that now. All right, that should have worked. Everybody forgot everything they knew about Prisma 1 and are fresh to talk about Prisma 2. Prisma 2 is an open source database toolkit that mainly consists of three tools. We have Prisma Client, that's there for database access, Prisma Migrate, and Prisma Studio. Prisma Client is the tool that we've just launched for general availability. So this is actually not accurate anymore. This should say general availability here, not in beta. But Prisma Migrate and Prisma Studio, the two other tools that we have available in the Prisma database toolkit, they are currently still in an experimental state. The core goals of Prisma really are to boost productivity and increase confidence of application developers that are working with databases. And that's mostly because the approaches that I've shown on a couple of slides before, they feel a little bit less productive oftentimes for developers, or developers aren't quite sure that they're doing the right thing when they're using Prisma. So the big question is, how can Prisma increase confidence and boost developer productivity at the same time? So let's look at a couple of things that contributes to this. Prisma boosts productivity and increases confidence by letting developers think in objects instead of SQL. And that's a big benefit of Prisma, that you don't have to perform this cognitive and this practical mapping of relational data to object-oriented data, but rather you can actually go and just think of your data in the way that you're used to anyway, as objects. Prisma also lets you work very intuitively with relations. And in my demo, we'll actually see what exactly that means. It means that you don't have to follow the model of relational databases with foreign keys when you're working with Prisma Client and perform joins to manifest relationships across entities in your application. But instead, you can just think about them a lot more intuitively in the way that you're used to in your programming language anyways. And then you also get auto-completion and type safety for all of your database queries, which really is a big benefit. Then there is a declarative and human-readable database schema. And that's a big benefit if you're used to reading SQL table definitions, which can feel very noisy at times. And the Prisma schema that Prisma introduces is basically a declarative version of what your database schema actually looks like. And it's human-readable so that you can check it into version control and everybody understands what your data structures actually look like. And this Prisma schema is also the single source of truth for your database and application models. In traditional database tools, you often have the problem that you need to synchronize the changes between your database and your application models. And with Prisma, that synchronization happens automatically by generating a client, a database client from the Prisma schema. All right, so let's jump into the live demo where I'm going to show you how you can get started with an existing Postgres database and introspect it with the Prisma CLI. Then we'll generate Prisma Client, which is this type-safe query builder that lets you send queries to your database. Then we'll explore some of the queries in a demo script, just a simple TypeScript script, really. And then I'll show you how you can get started to implement a REST API and a GraphQL API. And all of that is going to happen in the same application, in the same project that I'll be using for this demo. So let's jump right into the demo right now. So I'm starting here with a Postgres database that you can see on the right, and we have 3 tables here. So we have the post table, the profile table, and the user table, and there is a relation from user to post and user to profile. So here I have my project, my TypeScript project, which is really just very bare bones at this point. I don't have a lot of dependencies except for the required TypeScript dependencies. And the first thing that I'm going to do is I'm going to add the Prisma CLI as a development dependency to my project so that I can use it to introspect my database and generate my Prisma schema. But before that, I first want to create my Prisma setup using the Prisma init command right here. And what that does, it creates this Prisma folder on the left with my empty Prisma schema and a .env file to set my database connection URL, where I'm now going to input the credentials of my local Postgres database that I'm using. Next, I'm going to run the Prisma introspect command and see that 3 models have been written into schema.prisma. So let's see what actually happened here. And indeed, we can see that this Prisma schema that was just empty actually now has 3 models inside of it: post, profile, and users. And these 3 models, they mirror the table definitions that you previously saw in Postico. And one thing to note about this Prisma schema is that whatever you see here will determine the names of some of the queries in your Prisma Client API. And to make these queries a little bit more idiomatic, I'm going to change a couple of the fields here to ensure that they feel more idiomatic in the Prisma Client API when I want to send queries to the database. So with these adjustments, I can go ahead and add the Prisma Client dependency to my project. And now that I have that available, I can use that inside my empty TypeScript script right here and import Prisma Client from the package that was just installed. Then I'm going to instantiate it. And now I'm going to use this Prisma Client instance in a function where I'm going to send database queries. But in fact, because I don't want to write all of this, the boilerplate for this function, I prepared it right here as a snippet. So here we go. We've got the import, we've got the instance of Prisma Client, and we have a function, a main function that is being called down here. So let's go ahead and formulate our first query with Prisma Client. The way that it works is I can just use the auto-completion here in my editor to figure out the queries that I have available. And we see that I have 1 property here on this Prisma Client per model. In this case, I just want to go ahead and retrieve all the posts from the database that I have currently stored. I'm using the console dir here for logging so that later on we can also print nested objects. And I'm sending the query to the database. So let's observe the output. We see that there are 3 posts currently in the database, and they are all returned right here. And one thing that I noted on the slides before, a bigger benefit of Prisma Client is that it lets you work very intuitively with relations so that you don't have to perform any joins across your tables manually, but instead you can use the Prisma Client API to do so for you. And the way how that works is actually that you can use the include property here on find many, and then you just say you specify the relation that you also want to retrieve right here. So if I send this query again, we'll now actually see that each post object comes with a nested object on the author field. And I can go even further on this one. I can say that because an author has a profile, again, I can include that profile in the query response. And if I run the query again, we see that we get the author, but again, another nested object, and that's the profile for this one. So that's very nice. But what's even nicer, especially when using TypeScript, is that I get full type safety for all the results of Prisma Client. So as you can see here already, the post's result here, the result of the query is statically typed. And this works even to a level that you probably haven't seen before when it comes to database tools. So here I'm going to do a little experiment where I want to print the bio of the author of a certain post. So I can just traverse the relationship like this here, post.author.profile.bio, and I can go ahead and print just this. But the type safety aspect of this is actually here when I can go ahead and say that I want to select just the ID, for example, of the profile so that the bio isn't included in the query result. And we see that immediately the red squiggly lines appear in VS Code telling me that the property bio does not exist on the type that is generated for profile at the moment. I can include it like this again, and the error is gone. I can run the query again, and everything works. All right, so now that you understand roughly how Prisma client queries work, I want to show you how you can use it to build a little Express application. So I'm going to add Express as a dependency. And because I'm using TypeScript, of course, I also want to add the types that come along with Express. And again, I prepared a rough boilerplate for a very traditional Express application where we're just importing Express and we're setting it up to properly configure the responses. And now I can go ahead and implement my first route. And this route is going to be a very simple route that is returning all of the posts in my database. So again, just the typical Express boilerplate right here that you have when you're implementing a route. And the approach that I'm now taking actually looks very, very similar to what you just saw in the script. I'm just asking for all the posts in my database and return them using the rest.json function that's provided by Express. So now that I have this code implemented and this route implemented, I want to go ahead and test it. And the way how I'm doing that is by using a REST client right here in my editor. And this is the request that I'm sending. So just a GET request to the route that is specified that I implemented. So I'm going to send the request. And the response data we can see here on the right. So this route works. That's great. But what if I want to go ahead and actually write data to the database? For that, in a REST API, you typically use a post request. I'm going to make that to the same route here and implement it with the same kind of boilerplate. And this time, I'm going to use the create function of Prisma Client that's provided. And again, I'll be guided by the auto-completion for whatever I need to provide. So I need to provide the title. And that's a good point because I need to first extract the parameters that are sent in the post request from the request object that's coming in. And now I'll be able to just provide all of the data like this. And I'm returning, of course, the new post that I just created. So this assumes that people send over the title, the content, and the author email in the body of the post request. So let's go ahead and restart our server. And then also go back to our HTTP request that I have prepared and send this HTTP request to the API. And let's see if that works. All right, so we now created this new post with the title Hello World in the database. Let's just send the GET request again just to make sure everything worked. And we see that we now have this Hello World post in the database. So that's great. As the next thing and the last thing in this demo, I want to show you how you can now build a GraphQL API instead of a REST API in the same project. And for that, again, I'm going to delete pretty much all of the code. To be a good citizen, I'm also going to remove the dependencies that I added before and just add the only dependency that I need for this, and that's the Nexus dependency for the Nexus framework. While this is installing, I'm already going to import the schema object from Nexus, which is my main object that's used to configure the GraphQL API that I want to build. And the way how that works is that you use the schema.objectType function that's provided by Nexus. There you go. And you can define your GraphQL types like this. So the GraphQL types that I'm defining now are going to mirror the type definitions of my Prisma schema. So for this, I'm actually going to put them side by side. And for now, I'm just going to remodel the user and the post, but not the profile. So let's go ahead and add the ID, name, and email fields. ID is an int, and that's defined like this. Then we have a string, that's the name. And then we have another string, that's the email of the user. And let's do the same for post. It has a title, it has content, and then it has a Boolean field that's called published. With all of these different types in place, I can actually already go ahead and start my Nexus server. And the way how that works is using the Nexus dev command that I'm just using as my dev script right now. So here we go. I'm starting the Nexus server. And I can already see that there is a GraphQL server listening at this URL right here. Here comes the GraphQL server. So what does the GraphQL API look like at this point? Well, we already have the user and the post types as we defined right here, so that worked. But the only thing that's not quite right yet is actually the nullability of a few of these fields, because right now all of them are nullable, but that's not what's specified in the Prisma schema. In the Prisma schema, only the fields that are suffixed with a question mark are nullable, but all the other fields are required. So in order to make that right, I need to configure this in Nexus right here. And here is how that works. I just add this option to the fields that are required. And I save my file. And now we see in the playground that the fields that I marked as required indeed are now also required in the GraphQL API. So that's nice, but of course, an API isn't really interesting when you don't have any operations. So I'm going to now add a query that, similar to the REST API that you've seen before, will just return all the post objects that are currently stored in the database. And I'm using the Nexus API for this again. I'm building up a new query that's called posts. And they have the type post. And it resolves simply by returning all the posts of the database. So let's go ahead and test this query in the playground. And it works. We get the same queries, the same post records displayed that we saw before. So let's also go ahead and implement the mutation, a mutation to create a new post. T.field, create post. And this one should still return a post. And notice how I'm getting auto completion even for the types that I have here in my GraphQL schema. This takes 3 arguments. The title, it's required. The content, which is not required. And the author email that is required. Oops. All right, now we need to implement the resolver for this one. And this time we are again using the same Prisma client instance, prisma.post.create with everything that you knew before. We've got the data, and that includes the title. We retrieve the args from the title, and notice how even the arguments that I just defined in the line above are statically typed. And I'm doing the same dance to connect the author with the email that's provided. And let's go ahead. I saved the file, so the new mutation should show up. And let's go ahead and test this. Hello world. Content, I'll leave that on empty, and the author mail is alice@prisma.io. We need to make sure that we're using one that already exists in the database. So I'm creating the new post. Let's go back and retrieve that, and we see that we get this new post here in the database. All right, so this is how you can implement your GraphQL queries and mutations with Nexus and Prisma. If you want to save some boilerplate, I could now show you how you can add the Nexus plugin Prisma to the mix here, and then even get rid of the implementation of these kinds of resolvers of the boilerplate that you need here. And like that's what you can do. You can get rid of the boilerplate that you still need to write for these operations here by leveraging information from the GraphQL schema. I'm gonna go back to my presentation. That's it for this talk, and thank you all for attending.
Nico, thank you so much for that talk. It was really interesting to look at Prisma through the lens of like productivity and confidence.
Yeah, sure. I really enjoyed the talk.
We're going to do a Q&A now. Are you ready to take some questions?
For sure. Let's give it up. Okay,
so before we start, just a quick reminder that you can ask questions via the Slack channel, Prisma Day. If you haven't joined already, it's slack.prisma.io. You'll be able to join. So let's get started. We have one of the very first questions that was asked was, how would you recommend deploying an API using Prisma? Docker, serverless, node server, any other options?
So that really comes up to like what you want and how you want to deploy. So Prisma Client is flexible to be deployed in all of these deployment scenarios. You can deploy it in serverless environments, for example, with AWS Lambda, but you can also deploy it to a more traditional, like long-running node server. And in fact, like that's what we've a lot of seen people do like very successfully. And that's probably what I would recommend. But it is certainly possible to use the deployment scenario of your choice. And in fact, we also have a number of deployment guides in our documentation. So if you're curious how you deploy things, for example, to AWS Lambda, then be sure to check out our docs and follow the deployment guide there.
Cool. Now, A really important question here is, which editor theme do you use in VS Code?
I believe it's called solarized light or like solarized sunlight, something like this. It's my preferred version. I'm not that much of a dark mode person, so I really like my light mode, and especially for presentations, I think it's also always helpful to not have the dark background and have a better contrast. So yeah, I'm a light mode person, and that's solarized light, I think.
Cool. And I mean, we saw in your talk a lot of really nice auto completion features. Do they also work if you don't use TypeScript? For example, if you're just using plain old JavaScript?
Yes, absolutely. So you can use Prisma Client just with plain JavaScript, and there is not really a difference in terms of how you would use it. So the script that I showed and like the REST API and the GraphQL API that I showed in my talk, they were all using TypeScript. But you could equally well just remove pretty much the tsconfig file from that project, remove the TypeScript dependencies, and then just turn these .ts files into .js files, and then run it with the node command. So it really isn't a big, like in the way how you set it up, you don't have to do a lot of effort in order to get TypeScript to work, and then TypeScript has additional benefits, like even more so than just auto completion that you also get already if you're using plain JavaScript. But with TypeScript, of course, you get the type safety that when you have a typo somewhere, or like the way I showed how you can retrieve partial objects or include relations in your Prisma client queries, that the results are completely typed. These kinds of benefits you'll only get with TypeScript. But if you're using plain Node, you'll certainly benefit from the auto completion as well.
Right, yeah. Is this supported in other code editors besides VS Code? Do you have much experience with that?
I'm actually not 100% sure, but to be honest, I would expect that this is supported in most code editors. And the reason for that is that when we install the Prisma client like node module in your node modules folder, then we include the index.d.ts file. So the type definitions are included in the node module. And typically, code editors are capable of picking this up and then like being smart enough to show you the auto completion options like from these types. So I would expect that works also in other editors.
Cool. And a question that was that came up was, how does Prisma compare to Hasura?
That's a really good question, and a question that we hear a lot, actually. So I'm happy about the opportunity to clarify that a little bit. I talked about Prisma 1, and that you should forget everything that you knew about Prisma 1, because that was focused on GraphQL. And that's exactly also kind of the response to that comparison with Hasura, where like Prisma 1 and Hasura were kind of similar because both gave you the GraphQL for your database. Prisma 2 is actually very different. It's very different from Prisma 1, and it's also very different from what Hasura offers, because Prisma 2 has no native association with GraphQL anymore, right? There is no GraphQL layer inside of Prisma 2. It's really just a library for you to access your database, and in the future to like migrate your database. So it's really just like really an NPM library that you install inside of your project. And it's not some standalone server anymore that you need to deploy or that gives you a GraphQL API. It's really just on the same level as a SQL query builder or an object relational mapper. And these kinds of tools are also very different from what Hasura offers.
Mm-hmm. And if you were to develop an API today for a greenfield project, and by greenfield, I mean a new project that's being started from scratch, what kind of API would you use for that? Would you go down the REST path or down the GraphQL path these days?
I am a little bit biased just because I'm a huge fan of type safety. I like strongly typed schemas that tell me exactly what kind of queries I can send to an API and what kind of data I can expect in return. And the only way for me to get that with today's technologies is GraphQL. So for me, it would always be a no-brainer to kind of go with GraphQL, but in the end, it's always a question of kind of your use case and the things that you're building. If you're a small team with 1 or 2 people and you communicate every day about what you're building, then I think you might not need those benefits. But even then, I think it would be still beneficial to use GraphQL.
Right. And we have also a question from Pascal. You inferred the relations for the existing database, but what about the indices? Will I still have to touch the database for those? Can you comment on that, Nico?
I'm not 100% sure how exactly that's meant, but with like indices in general, like you currently can't, or like you can configure them also in your in your Prisma schema. But the way how that typically works is that you would probably configure it with SQL in your database and then introspect your database to have them in your schema.
Cool. Well, Nico, thank you so much for your talk. It's been really great. And have a nice day.
Thank you, Daniel.
Bye-bye. Okay, so we're now moving on, and I'm honored to invite my colleague, Martina Wellander. Martina is a Copenhagen-based Swede that comes from a C# background, but has recently learned that TypeScript is pretty neat. She's previously worked as a developer, a tech consultant, course writer, trainer, and documentation manager. She's also an illustrator and loves channeling her creative energies towards educational illustrations, which you might get a glimpse into today. And now Martina mainly looks after the Prisma documentation on the DevRel team at Prisma. So without any further delay, I bring you Prisma, who's joining us from Copenhagen.
Hello, Prisma fans and future Prisma fans. My name is Martina Wellander, and I am an education engineer at Prisma. I primarily deal with the documentation day-to-day, but today I am coming to you from not so sunny Denmark to talk about relations in Prisma. And for this presentation, we're going to go full circle, all the way from the database to the client API. And for each type of relation that we're going to explore, we're going to look at, first of all, how does that manifest in the database? What does the corresponding Prisma schema look like? And finally, what does the Prisma client API look like as a result? We are going to do all of this in 25 minutes, and we're going to try and keep it breezy, even though this can be quite a dense topic. So without further ado, welcome to Happy Table Friends, Relations in Prisma. And our journey starts in recipes.db, which is a SQLite database sitting on the ocean, smiling, with a bunch of tables in it. Most importantly, the recipes table. But it also has a bunch of friends, like authors and steps and ingredients and those sorts of things. And all of these tables have relationships between them. And I'm not going to assume any knowledge, but in a database context, the relationships between tables is represented by a database schema. And for reference, a database schema looks a little bit like this. Gorgeous. Prisma also has an idea of a schema, which is funnily enough called the Prisma schema. And it's a file that looks like that. Here is mine from this presentation. And it's written in a language called the Prisma schema language. And the Prisma schema represents exactly the same model as your database, but in this Prisma schema language. And there are two ways for you to create this schema. So you can either create it from the database. So if you're comfortable with SQL, you can create your database and then do something called introspection, where you literally point Prisma at your database and say, please give me a schema from this, and it will be automatically created. The second way that you can create a schema is to write it by hand if you are super hardcore. And then you can what's called migrate your schema from the schema file to the database. But whether you write it by hand or introspect, the schema is still the thing that binds your database and your Prisma client together. It represents your data model. And the reason we're bringing up the schema in the context of a relations presentation is that the Prisma schema includes information about the relations between all your models. So let's have a closer look at the first type of relation, which is a one-to-one relation. And a one-to-one relation might be something like one author has one profile. And actually one-to-one profiles or one-to-one relations, are quite rare. And you only really create them if you want to break up a big thing, like a person's personal details, into a bunch of smaller things. You might store the passport separately, driver's license separately, and that kind of thing. So in a database, this relationship is pretty simple. There is an author in a table, and they have a profile ID here, which links to the ID of a profile in a separate table. One author has one profile. Let's look at that in the Prisma schema. Here we have all the same fields. We have an author as a model. A model represents a table. We have the IDs, the profile ID, and wait for it though. Oh, actually, let me back up. I should mention that the profile ID is unique because one author can only have one profile. You don't want to share profiles. So far, it looks exactly like the database. We have the same fields, but here comes Prisma. And suddenly we have these additional fields, profile and author, which might look a little bit strange. And these are called relation fields. And they're going to feature heavily throughout this presentation because they are what define the relationship between models. Let's talk a little bit more about relation fields. So here they are for reference. Relation fields exist on each side of a relation. So you can see the author model has a profile field, and the profile field has a profile model has a author field, sorry. And at least one of those sides is going to have this relation attribute that describes a little bit more what's included in that relation. These fields, again, they don't exist in the database. They only exist on a Prisma level, and they are used to generate the Prisma client. So how you name these fields is quite important because it's going to show up in your API. And we're going to see relation fields come up again and again as we go through this presentation because they're part of every type of relation. So let's step through how this relationship field works, or relation field works in our current example, our one-to-one. So we have our profile field on the author model. The relation attribute references the profile ID, which is in the database. This is our relation scalar. And we're saying that this entire profile field via the profile ID should reference a key in the profile table. So if I go back, profile has a relation scalar, which references an ID on another model. So that's how a relationship is described in Prisma. If we jump to the Prisma client now, we can see how this all looks when it's generated into an API. So here we have an example where we are creating an author and at the same time creating a single profile. So the relationship has allowed us to link author and profile together automatically in our client API. And it works. It works in all sorts of queries. So that one was a create. This one is a find many. So find any author where the profile first name is Martina. And all of that comes from the fact that we were able to, in our schema, link author and profile. Jump ahead. Let's move on to a one-to-many relationship. A one-to-many relationship might be something like a author has many recipes. Other examples include one recipe has many steps, but it doesn't include one recipe has many ingredients. That's a many-to-many, and we'll cover that later. In the database, looks like this. We have recipes, tomato, sugar. Each one of them has, no, we don't. We have a, we have recipes, omelet or Thai green curry. Each one of them has an author ID represented by an integer, and that points to the ID of something in the author's table. So quite similar to the one-to-one, except that the author ID can be used multiple times in recipes. So one author can have as many recipes as they want. And there we go. I'm going to redo that bit. Nope, I'm not going to redo that bit. In the Prisma schema, this looks quite similar to the one-to-one relationship. So again, we have all of the fields that we had as part of in the database. We have the IDs of the author and recipe, and we have the foreign key, the author ID. And here come the relation fields. So we've got an author on the recipe and a bunch of recipes on the author. And the only difference between this and the one-to-one that we started with is that we have an array of recipes, or a list of recipes here rather than a single recipe. And then let's look at the Prisma client. So here we have a query to create a recipe where the author is also created at the same time. And we're also going to, as a bonus, create a profile. So we're jumping from recipe to author to profile here. And we can also find many recipes where the author has other recipes where the title contains prawns. Not really a query that you would normally run, but I'm just wanting to show you the kind of the flexibility that all these relations offer you. So we've gone from recipe to author to other recipes by that author based on that one relationship we've created, that one-to-many. The final relationship type that we're going to go into is the many-to-many. And this one is a little bit more complicated. So there are two types. Let's look at the first one, which is many recipes have many tags. And if we look at that in the database, it tends to look like this. And if you are unfamiliar with many-to-many relationships, we're going to talk a little bit more about this table right here that joins the two. This is called a join table. And it kind of stores information about how these two other tables should relate to one another. They don't really have a good relationship on their own. They need an intermediary to make sure that there's no drama. If we look at it with some data in it, you can see that we've got a couple of recipes here and a couple of tags. And if we look at the tag recipes join table, you can see that in the A column, which represents recipes, and I'll get back to that, we have 1 and 2, plain omelet and garlic prawns, and both of them are listed as B, or in B, as ID 24, which is easy. So the tags recipes table is storing information about recipes and tags together, the join table. And it has a strange name and it has weird columns. I mean, if you're familiar with join tables and databases, you kind of think that why are they called A and B? And that's because this is a magical join table, a Prisma specific, kind of boring, but magical join table. And to understand more, we can look at the Prisma schema. So when we generate or when we introspect that table and create a schema from it, this is what the schema looks like. We have tags on one side and recipes on the other side. So I can look at a recipe and get the tags, or look at a tag and get the recipes that it includes. But what about this little guy? So far, every single table in the database has become a model in the schema, but not this time. There is no tags recipes model. And that's because this is what's called an implicit many-to-many, which is a Prisma feature that introduces a little bit of magic. And here is the magic broken down and made less cool. So how do you make an implicit relation? How do you make implicit relation magic happen? Like, what is this weird little table with A and B columns? So the format of this table, the name must include an underscore. The column names must be A and B. And A and B points to, or A rather, points to the column that comes first alphabetically. So in our case, that's recipe. And then tag will be B. So it's a convention for creating a magic join table, which means that Prisma just knows how to relate recipe and tag. And that's what lets you have a schema that looks like this, rather than having a third table in here or a third model in here that links them together. So Prisma does some magic behind the scenes. And in the client API, it looks like this. So I am getting many recipes where the tags are, or any of the tags on these recipes are in this list. So anything with tag 1, 3, or 9 will be returned here. And that's possible because of that relationship. You can also go the other way because it's a many-to-many relationship. So I can look at a tag and find all the tags where the recipes contain the word tomato. So are there any breakfast tagged recipes that contain the word tomato, for example? But that's not all when it comes to many-to-many relationships. There is another type. So for example, many recipes have many ingredients. And excuse my tangent here, a tomato is just a tomato. But when you put a tomato in a recipe as an ingredient, there is an amount of tomato, which you need to store somewhere. And where are you going to store it? Now, if we look at the database, the traditional database way of doing this is to create a join table. Again, recipe ingredient you can see here, which has an amount. So recipes have ingredients, and when ingredients are inside a recipe, they have an amount. So it's a little bit more of an interesting but non-magical join table. So it's a little bit more familiar to those of you who do database stuff. And this in Prisma language is called an explicit many-to-many, because you are defining exactly how the relationship should happen, and the Prisma schema is going to reflect that. Let's have a look at the Prisma schema. So we have recipe ingredient and that recipe ingredient middle table there. And we have all of the fields that are represented in the database already. And notice that recipe ingredient, because it's a many-to-many, it has an ID that's represented by both the ingredient and the recipe. It doesn't have an ID of its own. And it also has an amount. And for the purposes of this presentation, we are just making that a string. But in reality, you would probably model like a unit. So you could have deciliters or grams or whatever you need, feet, 10 feet of cucumber. And now it's time to add the Prisma relation fields. So somehow we have to relate recipe ingredient to ingredient and recipe, and it's going to get a little bit messy. Okay, here's the first one. So we're going from recipe ingredient to ingredient. And you can see we have the same relation field here and a list on the ingredient side. And it becomes a little bit clearer when we use the API later. And then we need to relate recipe to recipe ingredient. Oh. So an example of how we would use this relationship before I move on is how often is tomato used as an ingredient? I can do that with the relationship I just created. I can also do something like, are there any foods that are never used as ingredients? The second part of the relationship is recipe. So here we have, each recipe has a list of recipe ingredients. And it's again represented by this relation field here. And it starts to get a little bit complicated with explicit many-to-many relationships. There's a lot of fields to keep track of, a lot of IDs. So what I like to do is model it and then try out the API and see if I like it. So let's do that. I mean, already this to me, the word recipe ingredient isn't really working. I'm getting this sort of face. But let's have a look at the client and see what we end up with. So Prisma client. I've generated my client from the schema, and this is what we get. So if we try to read through this, we're saying, find me many recipes where the recipe ingredient contains, or where some of the recipe ingredient could contain an ingredient named tomato and the amount is less than 10. I don't really like how this reads. It's accurate. It's saying where any of the joins contain tomato, but the fact that we have recipe ingredient and then ingredient, for me, is not really ideal. I just don't like it. And there's nothing wrong with the relationship at all. It just means that the client API doesn't really sound human to me. And there's two ways that we can get around this. So I mentioned that we can name the relation fields whatever you like. So I might rename the relation fields in this example and get something like this. Find me many recipes where some of the ingredients details include the name tomato. So here I'm kind of stepping down from ingredients to ingredient details, and it reads a little bit more human. So that's one thing I can do to improve it. The second thing I could do is to completely change the model, going back to the database. So I might do something like this. I got recipes and ingredients, and between them, joining those two, I have a measure with a value and a unit. And if we jump straight to what the API would look like, it would look like something like this. So find me recipes where at least some of the ingredients include a measure with the unit grams. So I can kind of say that as a sentence without it sounding strange. So that's my second option. But however you do this, hang on. I've actually forgotten my next point. However you choose to model this relationship, you can either make the change in the database or in the Prisma schema. You have flexibility. What I really like about how you can model relations in Prisma is that you can make tiny tweaks to make sure that the API makes sense. And it's fast. So I can very quickly rename a model in Prisma and regenerate the API and start using it and try to make it more usable. So I have a lot of flexibility there. And those are your three main relationships. Let's take a step back and summarize. So we've gone through a one-to-one, a one-to-many, and a many-to-many. And there are a few more details which you can find in the documentations. There's a one-to-one self relation as well. So I, a category, might have a parent category. I'm relating to myself. But those are the main three that you're going to be dealing with. We've had a look at how relations are represented in the Prisma schema with relation fields. And we've looked at how the Prisma client is affected when you change the Prisma schema. I can't forget it was too early. Yeah, I might do the in summary again. Let's back up and summarize what we looked at today. So in summary, we've looked at three main types of relations, and they match up to what you commonly see in a database. We've looked at the one-to-one. One author has one profile and vice versa. We've looked at the one-to-many. One recipe has many steps. And we've looked at two forms of many-to-many, an implicit one, where all you're doing is creating a relationship between two entities or two models without any extra information. And that was recipes and tags. And we've also looked at an explicit many-to-many where the join itself has additional information. So that was our recipes and ingredients with the amount being in the middle. And these relations match up to what you have in a regular database. This is not something that we've made up at Prisma. We haven't looked at one-to-one self relations. So that's something like a category might have a parent category, for example, but you can find out more about that in the documentation. We've looked at how each of these relationships or relations manifest in the Prisma schema. Specifically, we've looked at the relation fields, and you're going to see those in all Prisma schemas. And I really recommend using the Visual Studio plugin because it will help you build these relations without having to necessarily know the syntax off by heart. It kind of feels like playing a really satisfying game of schema writing. And finally, we've looked at how the way that you organize your Prisma schema affects your Prisma client. And you can find out more information about relations and relation queries and everything to do with joining models together in the Prisma documentation. So thank you for coming on this journey with me into the recipe database and exploring all the relationships between the weird little tables. Thank you for your time.
Martina, thank you. Nice having you live. That was a really, really insightful talk.
Hi.
So, I mean, go on.
Oh, I just said hi.
I really love the illustrations. I mean, I'm a visual learner, so this is like my way of learning. You ready to take some questions?
I am.
Okay, so Peter Belbin asked the question, do implicit relationships work with composite primary keys?
That's a good question. We recently made a change to make implicit relations a little bit easier to use, and that does mean that they don't now support composite primary keys anymore.
Okay.
And the docs are going to be updated with that change imminently.
All right. Okay, and then I'd also like to call out Jess Martin, who's been really sparking some really interesting discussions, especially about one-to-one relations, and them being like, well, I mean, it seems like the discussion's conclusion is that they're perhaps suboptimal in some scenarios due to the way that rows are stored. Do you have any thoughts on that?
I mean, I can say that I found it really hard to create a good example. But the only thing that I could find was that it perhaps didn't perform as well if you had a massive record that you had to return. But I think that the discussion is probably more well-informed than I am. So I would recommend heading into that.
Yeah, check it out. It's a really long thread that I believe was started by Jess Martin, right? Yeah. Okay, so do the modeling with database or modeling with a schema. Okay. Need to understand.
What makes more sense, model with a database or model with a schema?
Yeah, do you want to chime in on that?
You know, I'm quite new to Prisma, and I only recently found out about Prisma Migrate, so the ability to write your schema and then migrate that into the database. I would say that we've marked Migrate still as experimental, so it might change a little bit more in future, but it's really up to you. Personally, I really enjoyed the writing the schema by hand, but you got to make sure that it meets your production needs first. Migrate, that is.
Yeah, I've also seen a really nice tool shared recently where it's like you can actually model it visually and then export the SQL from that. I'll try to find a link and I'll share it in the Slack channel.
Oh yeah, I've used that. I use dbdiagram.io. And
yeah,
like
that's
you
the
can
new
export,
one.
Yeah, you can export like Postgres or whatever you want, and I found that really useful. It has its own modeling language. So if you don't like writing SQL, I don't like writing SQL. I always have to Google it. Then you can use that.
Okay. If we have no more questions, let's see. Do we have more questions coming? Oh, okay. Zurin is asking, where can we get more table diagrams and relationship stories?
Oh, well, I'm going to take that as free reign to draw more during work time.
Okay. And any best practices or libraries for a hierarchical self-relations?
I not that well versed in that, to be honest. Maybe we should raise that in the chat.
Okay, so that was coming from Pascal. So thank you, Pascal, for the questions. And this is your last chance. So if you haven't already, feel free to chime in and ask your questions on the channel. And if not, we will continue. Yeah, okay, so Jess Martin just mentioned dbdiagram.io is a sweet tool for people who are just learning relational databases. A lot of our students at Lambda School use it. Cool, so thank you for the tip, and I believe that was the tool that we mentioned.
Can confirm, really useful.
Yeah. Okay, so thank you so much for that, Martina. I really enjoyed your talk and hope to see you soon.
Thanks, everyone. Bye.
Okay, so we're about to take a break right now, and we will be back at 3:30 Central European time. Just a quick reminder that this event is really for you, and we're interested to hear from you. So we're interested to hear about what you're building and what are some of the challenges that you're facing in building those projects. So drop us a line on the Slack channel. If you feel like tweet on Twitter with the Prisma Day hashtag. And during the break, we'll also be running polls. So you'll see on the break screen a QR code. Feel free to scan that and that will lead you to the polls and we'll share the results after the break. If you have an allergy for QR codes, I'll also share the link in the Prisma Day channel. And as I said, we have stickers. I haven't shared the link already, but I'll drop the link to get the stickers in the Slack channel. And yeah, enjoy your break. See you soon. Hey, welcome back. And we're back for the second part of Prisma Day. And we ran a poll, and I think about 31 of you participated in it. And it's really nice to hear from you. So you can see on my right the results for this poll. If you haven't participated already, I think it's still open, so you can just join in. Yep, it's still there. And we have, so the first question we had is, where are you joining from? And we have people really joining us from all corners of the globe, from Russia, UK, Seoul, Jamaica, Haiti, Canada, Germany, Kansas. Wow, this is really Thailand, North Carolina, Paris, India, Netherlands. Wow, we're really covering a lot. Okay, let's move on to the next question, which is, what is your favorite developer tool? So we have TypeScript, VS Code, okay. Prisma, not surprising. Intel, okay, that's, I think my favorite answer so far is Google and Club Mate. To those of you who don't live in Germany or aren't familiar with Club Mate is actually just an energy drink that is very popular here in Berlin. So, okay, Reason ML, okay, really nice. And who's watching the Prisma Day? Okay, so everyone's got a coffee mug. I'm glad to hear. Mine is out, actually. I could probably use a refill. Do you use Prisma in production? Okay, so 57% of you are not using Prisma yet in production. How do you deploy your applications? Okay, that was, I believe, not part of the first part. Okay, we'll finish this survey part, and now we will open up the second part officially. So as I said before, welcome back. In the first part of the day, we looked at, we learned a lot from Zurin about the direction that Prisma is taking and our exciting round raise. Nicholas showed us how Prisma's functionality helps developers be more productive and confident when accessing their data. And then Martina gave us a deep dive into database relations. And building on this sort of database momentum, we want to share another really exciting Prisma announcement. So Prisma Day is not only Prisma's second annual conference, but it is also the launch of Prisma's Data Guide, introducing an online constantly expanding resource of tutorials and articles on databases. It has a lot of really interesting content on how to choose databases, how to use them in your application, and understand the underlyings of how they work. So we encourage you to check it out. You can do that at dataguide.prisma.io. That's data, D-A-T-A, guide, G-U-I-D-E.prisma.io. We'll also share a link to that in the Prisma Slack channel. If you haven't joined already, if you're just tuning in, I know that we have people attending from multiple time zones all over the globe. So if if you're just tuning in now, I invite you to our Prisma. You can do that via slack.prisma.io. And I'd like to thank all of the really interesting discussions that are being sparked on the Slack channel. Yeah, let's get to the upcoming talks. So we have 2 lightning talks back to back. Because they're short, we won't have a Q&A for them, but you can ask questions on Slack and the speakers will be there to reply. So let me introduce Sid and Warren. So Sid is a front-end TypeScript developer at Prisma. Recently, he's been dabbling with Swift and Rust, trying to get them to play nice. Currently, he mostly focuses on Prisma Studio, which he'll talk about today. That's actually the topic of his talk. And then Warren is a software engineer in London who's passionate about solid design and user experience. He recently launched a new app built on Prisma called Tomorrow, which makes it easy to schedule events and accept online bookings. Outside of tech, he's an avid cyclist and a movie lover. So without any further delay, I give you Sid and Warren.
Hey everyone, I'm Siddhant. I am a TypeScript engineer at Prisma, and I work on Studio, which is a database UI that ships with the Prisma CLI. So Studio is really a visual editor for your database, which means it lets you view or change your data. And like I said before, it ships for free with the Prisma CLI. So today I'm kind of hoping to show you how Studio might fit into your development workflow and how you can use it alongside other Prisma tools like Prisma Client, for example. So I've set up a little project / example for this talk. And for the next few minutes, I want you to assume that I'm building an app that shows you information about an NPM package, given its name. So this metadata is also scraped from the NPM website because for some reason I decided that that was the best way to do it. And I decided to store all this data in a Postgres database. So that's kind of what you see here. So this is the Prisma schema that's powering the entire app, so to speak. And we have 3 tables here. The first one is called package. It stores information about a single package. There's another table called user, which stores information about a user. And then there's a third one called version, which stores information about a version of a package at a given point in time. So let's say the first thing that we want to do is take a look at our data, try to understand it a little bit, and try to explore it a little bit. So the usual way that you would do this would be basically there are 2 ways that you could have done this. You could write a script that prints all of your data to your terminal, or you could kind of open this database up in a third-party database tool, for example. But there's actually a third way, and in my opinion, a much easier way to do this is to open your database up in Prisma Studio. So Prisma Studio is kind of aware that there is something called a Prisma schema that you see here. So you don't really have to give it a database URL or anything like that. All you really need to do is go to your project and type in npx Prisma Studio, and that's about it. For the time being, Studio is considered experimental, so you also have to provide an experimental flag here, but that's going to go away very soon. So I'm going to press enter, and there we go, Studio is ready. So I'm going to switch to my browser and open Studio up. So right away, you'll see that there's a whole bunch of data in my database because I kind of seeded it beforehand. And if you go onto the left side here, you'll see that there are 3 models here. So you have package, user, and version. And you'll see that these directly correspond to the models that you defined in your schema, which in turn directly correspond to the tables in your database. So you can kind of think of these 3 as the tables in your database, which they actually are. So what you can do then is kind of take a look at this data, scroll around a little bit. You can open 2 of them at the same time in 2 separate tabs, like I've done here. You can scroll down a bit. Okay, so this user table has this email, name, and packages. You can also open up the version table, and there's a whole bunch of data in here. So this is kind of like a very easy way and a very quick way to kind of get to your data as soon as possible. So let's assume that for the purposes of this example, I have discovered that there's a bug in my scraper, the scraper that scrapes the NPM website. And I've realized that there is a particular row of the Svelte package that has its SHA, which is this row right here, parsed incorrectly. So let's say what we want to do is we're going to find this row and we're going to try and manually fix it. So right away, you'll see that there's a whole bunch of data in here. If you go over here, you'll see that there's actually 30,000 rows in here. So we need a way to kind of reduce the number of rows in here. So what I'm going to do is apply a filter. So if you go over here and click on filter, you can click on add filter. Now this filter is actually almost exactly the same as the Prisma client's where argument that you're used to. What I'm going to do is I'm going to add a filter. I'm going to change this ID to say that the ID contains the word Svelte. Why Svelte? It's only because this is an example. Let's just assume that Svelte is the package that is incorrect. So right away, you'll see that we added a filter, and straight away, the number of rows has reduced down quite a bit. Basically, it's only showing rows that this filter kind of holds true for. But there's still like a whole bunch of rows in here. So let's also assume that I somehow magically also know that the package that we are trying to look for has its greeted at greater than this specific date that I have in my clipboard. So the exact data doesn't really matter. What really matters is that we are able to kind of dig into our data and figure out what row we're looking for. Let's also assume that I'm not really interested in the package name or the package columns, and so I'm just going to hide them, and even the name, if I'm being honest. So right away, you'll see that this is a reduced view of your entire database. When I say that this is Prisma Client, it actually exactly is Prisma Client. So what you can do is you can go into this little button here, click on it, and go to the code mode. And right away, you'll see that this is the actual Prisma Client query that will yield the same result. So if you kind of copy this query over, paste it in another script, you will see that the same exact data is returned. Now, this also works the other way around. So for example, if you have a buggy query that does not return exactly what you think it does, you can kind of copy it over and paste it back in here and see what data it returns. So it's basically a much faster way. It's a much faster feedback loop, I suppose. So now I'm going to switch back to the filters though, and we'll see that this is probably the data that we want to kind of change. So let's say this is the SHA that was incorrectly scraped. So what you can do is kind of double click on it to enter this edit mode, and let's change this to SHA-512 changed. Let's assume that this is like a valid SHA, for example. I'm going to hit enter to apply these changes. So while we're here, I also do not like that there is apparently some sort of sentience going on in my scraper. So what I'm going to do is I'm going to select this row, and I'm going to go ahead and delete this record as well, just because. You'll see that your changes are not yet applied to your database. They're still kind of in this pending state, like you see here on the bottom left. This is kind of a buffer in a way to kind of prevent accidental changes or whatever. But what you really need to do to apply these changes to your database is press Save Changes on the bottom right. And there we go. So these changes were applied to your database. You see that this extra row was gone and that this data was actually changed. So that's kind of all I had time for today. There's a bunch of other things you can do as well, like changing rows, changing relations, and all kinds of stuff. I'm just going to close all of this. So all of this you can do without having to set up a script or anything like that. So it's basically a really quick way to get to your data. So hopefully that proves to be useful for everyone watching. If you have any questions, feel free to drop them in our public Slack, and we'll try to answer them. And yeah, thanks for watching. Enjoy the rest of your day.
Hey everyone, I want to show you a thing I made with Prisma. It's a small little booking app called Tomorrow, which allows you to schedule classes and accept payments online. So I'll go for a quick demo of the app, and then I'm going to go for a quick coding demonstration of some of the technical constraints I faced whilst building the app. So here you can see on the left, you have a bunch of classes which repeat on a schedule, and then you can search through the calendar for certain dates. You can add filters. So then we'll go ahead and book a boxing class, for example. Add a bunch of spaces and some details, press pay with card, and then you get booking confirmation. So one of the main issues with building this was that the events obviously run on a schedule, and you don't want to add each instance of the schedule to the database, so you need to define a rule for how it repeats. And I'm using something called the iCalendar specification to do this. But then one of the other problems is that if, for example, you wanted to cancel the event on the 13th only or modify the event's time, you need a way of adding cancellations and exceptions to the rule as well. So I'll go through a quick coding demo now of how I achieved that. So for the sake of the demo, I've already written a bunch of boilerplate code. What we have basically is a GraphQL server which will return a list of events. So the schema in Prisma to do this, we have basically an event model which contains a bunch of information about when the event will occur, for example. So the rule will actually get saved here. Then we have a bunch of exceptions and cancellations attached to the main event. Then the actual event details are saved up in a separate model here. The reason for that is because the details could change between the main event and the exceptions, and obviously we don't want to repeat the fields across separate models, so we just link it this way. So if I run the migration script, that'll add everything into the database. So here we had an empty database, and now you can see we've got it full of all those models that we just had. But then I'm going to go and seed some data. Put something in. So cool, we have one event in here as well, and then we have a little rule explain when it will repeat. So inside the resolver, what we have here is a quick query which will just grab all the events from the database, and then it's running it through a utility function called expand events. This basically takes the event and it looks at the repetition rule, and it will just repeat it for whatever the rule says. So then if we launch the server, and then go ahead and run a query. So here we can see that, for example, we've got a yoga event which is repeating daily, and then it's obviously the same event repeated, so all the data is identical. Now, in the case of adding an exception, we want to be able to say, for example, just change the first 2 days to happen only in the morning rather than 6 o'clock. So here we have more information about the exception. The main things are the original date and then the new date. So the original date is the date that's being replaced, and the new date is obviously what the new time is. And then that's also linked to event details, so we can change things like the title or the price for that exception as well. So if I go back into my Cedar file and add some exception data, cool. So then here we have some information about an event exception. And then we also need to go and update the event inside, where are we? Expand events, that's the one. So just to give a brief overview, the way expand events works is it's using something called rule, which is an NPM library. It's a representation of something called the iCalendar specification. Basically what we do is we pass the event in, we read the rule out, and then we print a set of dates which between 2 other dates, and then we just basically spread the event over each date so we have it all duplicated. Now when we're working with exceptions, we need to make some small updates to this function. So here's something I wrote earlier. So the only update is that now when we're passing the exceptions in, we exclude all of the original dates from the dates that get printed out from rule. And then afterwards, we concatenate to the original array a bunch of exceptions with the exception details here. So if I save this, and then the one other thing we need to do is make sure that we're actually requesting the extra data from Prisma. So I'll save there as well. Then yarn dev. One more time. Cool. So here we have now an exception to the rule, so yoga in the morning. So you can see that on the first it's at 6, then on the second it's at 9, and then on the third it's at 6 again. So that event's been replaced completely. So the one other thing that we would want to do is, rather than replace things, you just cancel things completely. So it's a very similar situation to before. We have another model called event cancellation. And here we have just the original date that we want to remove, and then just a link to the event ID that we're actually moving. So then if I go back into Cedars, and I'll add an event cancellation to the database. Cool. And then we'll go to cancellations again. I can see that we have an entry here. So the 5th month at 6 o'clock is going to get cancelled completely. And then back into the resolver, and now I need to make sure that cancellations is being fetched as well. So I'll just add an extra thing to the query. The cancellations will now come through, and then if I look in expand events again, we have another slight change to this function. So the only difference here is that now we're also mapping over the cancellations, and they're getting excluded from the outputted dates as well. So I'll save that and run the server one more time. Cool. And then do the query one more time, and then you'll notice that the 5th month has now disappeared completely from the query. And basically, yeah, that's a little demo of some of the things I did with Prisma. I've also added here a link to the GitHub repo for the demo, and thanks for listening.
Thank you, Sid and Warren, for those short and sweet lightning talks. I want to now introduce Emil. Emil is a backend and DevOps freelancer. He helps enterprises build products using the latest practices like GraphQL and infrastructure as code. He's currently on his 2nd contract using Prisma 2 in production, and has been a very, very active member the community and a contributor to the Prisma project. The title of his talk is especially timely. It's a serverless Prisma 2 with Google Cloud Platform Cloud Run. So without any further delay, I'm going to give up the stage to Emil.
Hi, everybody. So the topic of this talk is serverless Prisma 2 with GCP Cloud Run. So during this talk, we're obviously going to talk about Prisma, Docker also, so why we should use Docker, how to build an efficient image. After that, we're going to jump to Cloud Run. How is it a good serverless platform for us? How to do the secret management, and finally, how to do the deployment. And in the final stage, we're also going to talk about how to integrate with an existing database. So a bit about me first. I'm a backend and DevOps freelancer based near Montreal, Canada. I started working with Prisma at the beginning of the year, and I really enjoyed the technology. I have already done 2 projects for some clients using the technology, and I'm an active member of the community. I contributed a bit to the JS client and also to the Rust engine. And I'm helping a lot of people. So if you need any help or you have any question, feel free to contact me to any of these contact information. So let's jump into the talk. Prisma 2 is really great for development. Like, the engine is downloaded in the background for you. Probably a lot of you didn't know there is an engine at all. The CLI makes client generation easy. TypeScript has first-class support. The imports are all from @Prisma client, making them easy and convenient throughout your project. And most importantly, the magical autocomplete that we love at the end of the day, and that's what makes us productive from day to day. But I also found that Prisma is hard to deploy somewhat. By default, nodes only understand JavaScript, so if you're using TypeScript, that's already a problem. The CLI is usually not included in the production dependencies, only in dev dependencies. We do need an engine already to run in production, not something that is downloaded after. And we want to make our build artifacts small, so they're easy to deploy in production. So if you have something like a monorepo with an API package and a common package that is not published to any central repository, you might have a hard time to deploy Prisma. And my solution for you today is to use containers, and most specifically the Docker and Dockerfile specification. So why containers? Most of you are probably already familiar with the idea of containers. So they are ready to run. They contain all the dependencies and your application code. Usually you only want to ship your JavaScript code, the generated JavaScript code. And they run on a variety of platforms. Like I said, today we're going to use Cloud Run, but you could use a Kubernetes cluster. You could also use Docker Swarm, Mesos, or any proprietary thing that runs Docker files. And just a small distinction between an image and a container. So usually I want to refer to an image. The image is like a blueprint, and the container is the runtime. Like if you build a house, you have the blueprint and the house. So the container is the house. So let's build one. This is the most simple Docker file you usually find for a node project. It is simple, but is it really good? No. There are several problems with a simple Docker file like that. So the first one is you're always using the latest node version because you didn't tag the node that you're going to use. Usually it's not something we want to do in production. Next up, we copy everything from the local disk to the Docker image. And the way the Docker caching works is usually per line. So if something changes in one line, all the next lines are going to be invalidated and needs to be rebuilt. And we want the caching to be as efficient as possible, so our build time is as low as possible. So that means that every time you change one file on your file system, it's going to invalidate this line, copy everything back, and then the next line is a yarn install, meaning that you're going to install your dependency every time you build your container. So also the problem with yarn install is that it's installing both the production and the dev dependencies. So you have a bigger, you don't need the dev dependencies in production, right? And finally, you have a yarn build. So that means like you take your TypeScript code, generate some JavaScript code, but you still have the TypeScript code inside your image, which is not needed in production. And frankly, it's not a good practice. So you can, like most of the best practices I'm going to use are based off Docker blogs of Docker best practices. You can read about them more at the link below. So here's my improved build that I design for my projects. I originally posted it on my Medium blog post, and it's a lot beefier, it's a lot more complex, and we're gonna go through it to see why it's a better approach to building a Docker image for Prisma. So the first thing you'll notice is we're gonna use multi-stage build. So that means like you can have all the dependencies during your build, because effectively we're going to build 3 images: the base image, the builder image, and the runtime image. So only your production dependencies will be inside the runtime image, and you copy only the thing you need for runtime inside the final image. So that means you won't have the TypeScript code inside the final image. The size reduction is usually pretty significant. So without any optimization, you can go from 1.3 gigs to usually 200 or 300 megabytes for the production image. One thing to note is I usually prefer to use slim images to Alpine images, even if beginners usually use Alpine. This is my personal preference, but I found that usually the trade-off between Alpine to get from slim to Alpine is that you lose glibc and you gain muscle, and sometimes runtime code is not like, you can have unexpected behaviors with muscle. So I prefer the glibc implementation, and also you lose the APT, which is kind of a big deal since the package manager on Alpine is fine, but not perfect. Let's just go back a bit to show like the multi-stage build. So the first stage is the base that we just saw, and the second stage will be the builder around here, and the final stage is the runner, the actual runner. That will only this part will be shipped into production. So we go forward, and then we are at the builder. So here in the builder, you can see that we copy the package.json and tsconfig.json with this star.json. And this is interesting because that allows us to cache those production dependencies and before we copy any of the other files. So that means like every time, since the caching is done per line, and if you invalidate one line, all the next line will be discarded. If we don't modify any of our JSON files, everything here will be cached between our builds, and that will improve the build time quite a lot. One thing to note here is we're installing the production dependencies first. This is a trick because our common package is not published to any central repository. That means if you try to install your production dependencies inside the final image, it will say that it cannot find the common package, which is normal. So one trick is to install them before your dev dependencies, so they are not polluted from your dev dependencies, and copy them over to somewhere else. If your common is either published to a central repository, or if you don't have a common, you can just skip this step and put the install of the production dependencies inside the final image. But then you also will lose the caching, because here, like I said, all the next steps will be invalidated on every build. So I prefer to put them here. Notice that we follow the symlink here. This is needed because common is usually, the common package will usually be symlink into the API package node dependencies. And we also use no hoist. So that basically the API package dependencies are inside its own node modules and not merged together with all the other node modules. That makes it just a bit easier to just get the runtime dependencies of API alone, and not other node modules that you might have. And finally, we're installing the dev dependencies around here so we can proceed with the build. So the next step is to basically copy your source code from API and common package. So that will mean, like I said, that you won't have to refetch your dependencies on a rebuild if you cache your builder image. And this is very great to speed up your build time. Next, we're gonna the common package first, generate the Prisma client here, and then build our API package in the right order. Obviously, if you have other packages, you need to be in the right order for them to build correctly. And then we go from the builder stage to the runtime stage. So we copy everything we need for the runtime. So first the dependencies, so our production dependencies that were copied in temp. And then some of the generated stuff that from Prisma, so the Prisma client and the .Prisma client inside our node modules, our dev node modules. And then finally, we copy the common distribution to our common distribution of our node modules. And the last step is the compiled JavaScript code from our API package to actually run it. And also, if you might usually want to copy back your tsconfig and also your package.config, .json, sorry, since this will allow you to run script basically. And the really last step of the build is to drop the privileges, because by default, Node runs as root. It's usually not a good idea to run your stuff as root. If you have some kind of vulnerability, basically the attacker will have root if they drop out of your application. And also you can ensure that if right way to go about them. So now what? We have an image, we need a runtime, we need a database, and my solution for you is to use Cloud SQL and Cloud Run, which are both a product of GCP. So why Cloud Run? It's a serverless platform, meaning you don't have a server to maintain. There is still a server despite the name, but you don't have to maintain it. It's also a pay-per request. So that means like you start paying when your first request comes in and you stop paying where your last request comes in. So if you have a low traffic, or if you're a startup, it's a really great way to save money. Or if you have just a small project. And it's almost infinite scale. We're gonna see what is the limiting factor actually. So it's based on Knative, Kubernetes Knative, which is like an open source technology. So it's basically their way of implementing this technology with a GCP Cloud Run. So it's easy to switch to GKE, which is the managed Kubernetes if need be. They do have an offering called Anthos if you have an existing cluster or if you really want to run on your own cluster. That works pretty well. And basically what we're gonna get from Cloud Run is an HTTP endpoint that you can use to ping your API. And we're gonna see that in a moment in the demonstration. So, but first let's talk a bit about the database since it's an important part of our deployment. So I decided to use Cloud SQL, but it's not necessary. It has a great integration with Cloud Run, but anything else could work too. One thing to note is usually your SQL database is going to be your limiting factor because of the way the database were designed, and it's usually old software, even if it's good software, it's usually limiting on the number of connections. Since every connection is using a bit of RAM, it's not a serverless platform where you can connect as many people as you want to the database. So how to measure the connection, it's not an exact science, but Prisma uses these formulas to determine how many connections they are going to use per instance of Prisma client. And then usually you have 100 connections for a basic database, not modified or not optimized on GCP. So if you have only one CPU, that means like you can have usually 33 instances, but I would still give it a bit of margin of error because it's not a perfect science and we don't want to bust the connection limit of our database. One thing to make sure in GCP, if you use Cloud SQL, is to enable the Cloud SQL API. So I have a small demonstration for you that just shows how to set up your database if you've never done it inside GCP. So let's go full screen. So here we choose the Postgres database. We give it a name give it a master password. It doesn't matter since we're not going to use the master user. Choose a region, whatever you want. For this demonstration, it's important to use a public IP. Even if it's not reachable from the internet, since it has a firewall, we need a public IP. Then it's always a good idea to choose a backup during the night and choose high availability if you're in production. So it creates two machines basically, and you can swap between the two. So you have less downtime if your database dies. So here we're going to create the database. Next, in the meantime, we enable the Cloud SQL API, admin API. That's something people always forget for some reason. I did that the first time, so that's why I'm showing it to you, so you remember that you need to enable this API. Otherwise, you're just gonna not work. It's just gonna not work. After that, I'm creating a new user. So usually what I prefer is to create a service user that I can descope later. So it doesn't have like drop permissions, for example. So you can protect a bit your database and limit the permission. And finally, you probably want to create a new database too, like a logical database, since using the default one is usually not recommended too. So it's just a simple video to show you how to go along and create a database. Also, I wanted to touch a bit about the migration. So I'm not going to talk a lot about it. I've already, inside this demonstration, it will already be done for you. The way to go about it is to connect to your database using Cloud SQL Proxy, which basically opens like a tunnel between your computer and GCP, so you can talk to your database. Create another user for migration. It's always a good idea, and the user with higher privileges that is not the same as your service user. And if you're using schema first, you can use the experimental migration. I found that it worked quite fine for basic needs. And if you're using the introspection, then use whatever tool you're already using. I prefer to do the migration during usually this CD, the continuous deployment phase. So whatever, if you're using GitHub Action, Cloud Build, anything will work. As long as you have a public IP, the Cloud SQL proxy will be able to connect to your instance. So yes, I'm not going to go much more over migrations, but if it's a topic you want to hear more, let me know and we can discuss it later. Next up, I want to talk a bit about the secrets. So why do we need secrets management? So you should not put secrets inside the image like you don't put secrets inside your code. It's not secure. We just want to have the secrets live in the memory at runtime. So one great thing is that there's a service called Secret Manager inside GCP where you can keep your secrets secure, have an easy time rotating them, and see like also who has access, since it's an access based on service accounts. And if you need to keep track of like who rotate those secrets when for compliance purposes, it's a really great service. And what you're going to put inside this secret for the database URL is this format here. So it's a pretty typical format for Postgres. And the only difference is you have to use the localhost and the host file for Cloud SQL. So here we're going to see it in action. So first you copy your connection name from your database. Then you go over to the secret manager, create a new secret, give it a name, and just write the format that I told you. And here you can see a bit like the first version, and we can create new versions. So the only problem with, I'm gonna full screen. So the only problem with secrets is there's no real integration with Cloud Run. So my solution was to use a custom script that download the secret at the startup, write them into a .env. You might require some Docker file changes since we dropped the permission to Node, which doesn't have any write permissions, and inject them as environment variables inside your secret. So that's your startup script. That's the changes you need to make to the Docker file. Just give it some folder you can write to. And obviously you need to use in your schema.prisma the env thing. So finally, let's deploy the service. So here we have a pretty standard mono repo, like I said, and with an API package. I don't have a comment here, but still it's the same thing. So here it's also using Nexus. It's a GraphQL API, pretty standard. So, and also the Docker file, like I showed you inside the whole presentation. So it's not really different. So the first thing you'll need to do is create a new service account for your service. After that, you have to give it some permissions. So the permission to read the secret we just created. After that, it's the permission to connect to the database. And finally, we're ready to build our Docker image. So so it's usually using all the caching. So you see it doesn't take long to build. And finally, we push it to the GCR, which is the container registry of GCP. Next, we go into GCP. So GCP Cloud Run, we create a new service. Usually you want to be in the same region as your database for latency purposes. You also can use here the Cloud Run for Entos. Give it a name, and usually allow unauthenticated is what you want, because if it's a public API, you need people to query your API. Select the Docker image we just built, and go into the event settings. So here you have the container port, the container commands if you need to change it, and then the service account you need to select the one we just created. Usually you want to have like the maximum capacity, which is 80 right now, 80 concurrent requests per container, the request timeout, the CPU, memory, you can all customize, and you want to change the auto scaling. So currently it's 1,000. Like I said, your database is gonna explode if you leave it at 1,000. So 5 is usually fine for starting. You can increase it up to 35, 33, like I said. Give it still a bit of a nudge. Finally, you want to put some environment variables, so the node production, but don't put anything sensitive here since it's not encrypted. And the last stage is to connect your database. So we're gonna use the Cloud SQL connection with our database here. That uses the public IP. If you want to use a private IP, you can do it with a VPC connector, but it's out of scope for this presentation. So finally, we create the service. And then we can see that it started. We have the randomized URL at the top. And then we up into Postman. And then we're going to just do a small GraphQL query to see that the service works. And then we have the response. Cool. So let's go back. So a bit about the downside of this service. There is no integration currently with GCP Load Balancer, but it's coming soon. I tried it and it's pretty great. I can't talk much about it because it's still under NDA. Also, there's no minimum number of instances. That means that if your service doesn't receive any requests, it will stop all the instances automatically for you. That means that you will have a cold start on the first fresh container that runs. Like you saw in the video, it's usually 6 seconds. That's my experience too. So if you can do some lazy loading, it's usually a front-end concept where you load the pieces of code and instead of like loading everything up front, it could become a backend concept with serverless, which is because the cold start is usually a problem with any serverless platform. So prefer lazy loading if you can. And you can also kind of cheat the platform by using a GCP health check that pings your service. So you're only going to pay for like this health check every, I don't know, 30 seconds or so. And it's going to keep at least one container running in the background for you. One other problem is also that there is no background jumps. So usually you need a worker with a queue, but it's usually fine for that. And the Prisma engine used to die, but it's really not a problem anymore. We just need to keep it in mind, so because it's more sensitive to regressions in the future. So going further, We can do DNS with name mapping, TLS, monitoring, and infrastructure as code. That's one of the topic I really like. Usually I use Terraform, but I also discovered Polymi recently. So basically you write code to build your infrastructure, and Polymi allows you to write TypeScript code to build your infrastructure. So that's the same thing that we've built in the command, but with code. So in conclusion, Prisma is really production ready. Containers are a nice way to package your project, and building a good image is not easy. Cloud Run is a good serverless compute platform. Cloud SQL is not perfect, but it does the job. And do not be complacent with your secret management. Thank you very much. And if you have any question, I'm here for you.
Emil, thank you so much for your talk.
Hi. Yeah, my pleasure.
I really enjoyed learning about some of those Docker optimizations and like what's possible these days with Cloud Run. I think it's like super cool to see how like Docker and containers in general have really solved like the packaging problem and allowed for, I mean, I think most of the serverless platforms these days are essentially running on containers. So are you ready to start with a Q&A?
Yes.
Okay. All right. I mean, I think I have also a question. So I think one of the interesting things I'm curious to hear about from your experience is what are some of the trade-offs when comparing something like Google Cloud Run with serverless platforms like AWS Lambda, Netlify, and Versal?
Yeah, great question. One thing I found is most of like other serverless platforms are still using or their custom infrastructure in the sense that you need to use some kind of handler that is specific to that platform, or you're using like serverless, the serverless framework. So with the container approach that the Google Cloud Run has, you just take your already existing workflow and frameworks and what you're used to working with, and then you just can translate that directly to a production-ready environment. And you just need to listen on the right port for it to work, and that's it. So it's really, yeah.
I also imagine it's much easier for local development because essentially in your local environment, you're running exactly the same runtime as you would in production.
Yeah, exactly. I found that it's basically you're running an Express server like you would put in any production environment or whatever server you're using for a node or another language.
So someone asked whether you can share the link, and you shared the link to the article, which was sort of the basis for this talk. So if you're interested, you can look in the Slack channel and you'll find the article which explains all of this. The talks will also be obviously available later. And the question came in from Pascal, who's also really active with the question. So thank you, Pascal. Is Google Cloud Platform cheaper than AWS Lambda in your experience? And I imagine he's talking about Google Cloud Run.
Yeah. Well, I looked at the number because I actually didn't really check, but because it is a bit more expensive than Lambda, but I think the trade-off is acceptable. I still think that if you're switching from a 24/7 running machines to something like serverless, you're still going to see some cost reduction anyway, because you're only paying when you have requests. So unless you're like having really big scale, then it makes sense more probably to switch to more instances than paper requests. You're still going to see a lot of cost reduction.
Right. And under what kind of conditions would you recommend moving from something like Google Cloud Run to Kubernetes?
Well, yeah, there are some of the downsides, like I talked about. If the latency for starting a new app, like the 4 to 6 seconds, is not acceptable, I think it's probably not the right product for you. And also, if you have the engineering team or scale to set up the Kubernetes and maintain it and update everything, like even if Google does a lot of stuff for you, updating the nodes and everything, it's still a lot of overhead that you don't have to worry about if you're a small startup and you're just starting. You just want something up and running quickly, or you just have a new project and you want to do a proof of concept or something. You don't want to spend the time to set up your whole Kubernetes cluster. So those I think are the most important things. Yeah.
And you talked a bit about migrations of the production database in your talk. Can you expand a bit on that subject? I'm really sort of curious to hear about, like, how do you make sure the database is ready when a new version is deployed?
Yeah, I've seen two. Well, it's really on your CI system. From my experience, I think I've done one inside the GitHub Actions and one inside Cloud Build.
Where you ran the migration inside the CI pipeline?
Yeah, exactly. You just you build your Docker container, you push it, and then you run your migration. And what's great with it is you can reuse basically the container you just built to run the migrations because they have the Prisma code and Prisma migration inside of the builder, for example. So that's a great way to do it, and it works well with Cloud SQL to connect to your database.
And lastly, let's see if we have any. Okay. Also, you talked a bit about, you went into detail into some of the optimizations with regards to Docker builds and caching. Can you talk a little bit more about some of the tricks there that help with caching?
Yeah, sure. I think the best trick is really to have your package.json copied before, and then your dependencies after that. So not copying your code at the beginning is really the biggest trick. And after that, what I did is basically you copy your production dependencies before your dev dependencies, so they're really like separated, and you only have your production dependencies at the end, and not a mix of dev and prod dependencies, which you don't want. So
that's what you did with the multi-stage build there, is that right?
Yeah, exactly. Okay. So you copy your production dependencies somewhere else in the meantime. So you're not trying to fight your Yarn package to like remove some dependencies that you don't need. You just like really do it in order. And yeah.
So we had another question from Pascal. Would subscriptions be possible OOTB with such a setup? Not so sure what he means by OOTB.
Currently, no, not with Cloud Run. There's something they were working on. But the problem with subscription is they are based on WebSockets, and the WebSocket requires a constant connection. So it would be like paying for one request that never ends, and it's not supported right now. So you can look at something like Pusher or another third-party system if you want to do. But it's not going to be native to.
Oh, okay. So basically with Pusher, you would have something like a WebSocket connection from clients connecting to Pusher, and then the Docker containers would just push to Pusher, essentially the events for the, I see. Okay.
Yeah.
Okay, Emil, we're coming towards the end of the Q&A. Is there anything else you would like to mention before we finish off?
I'm glad that people enjoy my talk, and don't hesitate to contact me if you have any questions or you need help on anything.
Thank you for your talk, and also for all of your great contributions to the Prisma ecosystem. I think you shared with me recently the awesome Nexus repository that you started. So I'll probably share a link on the Prisma Day channel if you're interested in that. And thank you, Emil.
Yeah, thank you very much.
Okay, so we are about to take a break. Before we take a break, a couple of notes. So probably said it many times, but we're available on Slack. We also have the Prisma Day stickers, which you can get. I've shared the link on the Prisma channel, on the Slack channel, sorry. And we'll also be running another poll in the break. So be sure to check out the QR code. I saw a lot of submissions for the first poll, which I'll share. And it's great having you all, and keep it alive. If you've joined just recently, please check out. We've recently released the Prisma Data Guide, which you can check out on dataguide.prisma.io. And enjoy the break and rest a bit. We'll be back in 5 minutes. Welcome back. I hope you're refreshed after the break and ready for the third part of Prisma Day. We ran a poll in the break and many of you participated. And I'd like to share some of the results. So the first question was, how do you deploy your applications? And 28% of you answered for the platform as a service. So something like Heroku or Google App Engine. Interestingly, most of you, 42% of you, are using function as a service or a serverless platform. This is really interesting. And we have 24% who are using Docker with Kubernetes. That's always interesting to hear more. And then we had a question, what do you like most about Prisma? So we had auto completion, ease of use, how easy it is to get set up and running, auto, simplicity, a nice structure. Oh, also the community and the team just behave like peanut butter and jelly. Awesome. Okay, I love that. Oh, thank you. Blazing fast developer experience, automation of it all. It's very Railsy. It's great that you can manage the DB using Prisma Migrate, and it handles almost all of the annoying repetitive steps. So thank you for participating. And then 35% of you answered to the question, are you there? Wait, where? So actually, if we look at the results from the first survey that we ran, we actually had more people joining, and really we had a lot of people from China, Ukraine joining, Colombia, they're probably joining a bit later because of the time zone difference, Romania, Russia, Poland. So welcome to everyone who's joining now, as we have the East Coast and perhaps even the West Coast joining us in the US and the Americas in general. And sort of coming back to Prisma Day, in the previous part, we looked at Prisma serverless deployments, Prisma Studio, and we even looked at an application that Warren built with Prisma. In this part, we're going to delve a little bit deeper into the Prisma developer experience and how Prisma ties together with the broader ecosystem, including things like GraphQL. So on that note, I'm really excited to invite a colleague of mine, Tim Zuchanek. Tim founded the AI painting app wizard startup and joined Prisma afterwards as its first employee. Tim is now leading the core TypeScript efforts at Prisma while contributing to open source projects like even the TypeScript compiler. And a fun fact about Tim, he loves orcas. Orcas, by the way, are killer whales to those of you who aren't familiar. I personally had to look this up, and thinks that they're one of the most underrated living beings. So Tim, I invite you to also share on Slack why you think they are the most underrated living beings. So now, without any further delay, I bring you Tim.
Hello, my name is Tim, and I'm working for Prisma as a TypeScript engineer, and I will talk about how Prisma solves the N+1 problem. So as I said, I'm working for Prisma as a TypeScript engineer, and I'm living in Berlin. You can reach out to me at Tim Zuchanek on GitHub or Twitter if you have any questions later. So what we'll cover today, we will talk about this mysterious N+1 problem, what it is about, and we also will see how we can solve it and how Prisma is helping us with that. So the N+1 problem is basically as old as data is, as old as, for example, SQL. Here we see a GraphQL query. For the people not familiar with GraphQL, we will dive a little bit into it and explain how this query is being resolved. So we will dissect this a little bit. And as you can see, we are querying for a user. Here we say something like a user, take 10. And what is this doing? This is giving us the first 10 users. It's giving us the ID, email, and name, but also all the posts that the user did in our blog. We just have an example blog application. And for every post, again, we get the scalar fields, ID, title, content published, but we're also getting all the comments, the first 10 comments that have been posted to that post. And as you can imagine, there is quite some data fetching involved here. And so how would we actually resolve this? In order to understand this, we have this graph here, this illustration. And what this is basically about is that in GraphQL, you always start at the top level. In our case, it's the users. We start with the users. So we resolve the first 10 users. And we get, for example, George, Alice, and Bob. And now for every user, where we got the scalar fields already, we now need to resolve the posts. And again, we go through all the users, get all the posts. That's the next level of the query. And again, in our graph, so to say, we need to traverse this graph. Yeah. How is this a graph? Any relational database you can see as a graph. You can just say that the rows in the database are basically the nodes, and the relations between these nodes are the edges. Yeah? As we see here, a post is related to comments. And again, after we got all the posts, we now get all the comments for the posts. So we have to do requests that return the according data. And so let's look into how we can implement this. We're using the GraphQL.js implementation to resolve this in Node.js, and we wrap it with the Apollo server. And what is happening here is that we say, okay, we have a resolver, and a resolver is basically the thing that is responsible for giving us the data. And this thing is fairly simple. We have a SQL query here, and we say, please select all the columns and give us back only the first 10 users. And again, as soon as we have the users, we continue and we say, give us the first 10 or whatever we query for posts for the user. And again, we go one level deeper. We have a select specified here for each post. And for each post, this select will be run. The GraphQL.js engine is passing us in the post object that we already resolved in the level before. And now we can just take the post ID and say, give me all comments that are pointing to the post with that post ID. So let's run this now and try out how this stuff is working. So I prepared a simple server. Whoops, let me quickly open that. Yeah, there we go. Apollo with Postgres. So let's log into this. We're using the GraphQL Playground, which is a console that helps you to query the GraphQL data. And so we will send this same GraphQL query that we have been seeing before in our slides. So let's query this. Okay, as you see, we get back the data as expected. We get JSON data back. We have the posts. Again, the posts have comments and so on. So this is what we expected. And now let's actually look into the queries that have been generated under the hood to make this happen. And as we see, whoa, we have a lot of queries. And the problem, we have like many select queries here. And the problem is really we're generating so many select queries per post. And what is actually happening here? This is really a lot. The truth is we're probably sending 101 queries, and this is exactly the n+1 problem. And what this is about is that we say for one user, we have to do n queries to resolve the data for the posts. And that's exactly the n+1, or you could also just call it 1 plus n. And let's look into that in our illustration that we had earlier. So here we see, okay, the first query, this is now just the numbers of the queries. The first query is the user's query. We don't get around that. We need to get the users first. Then for each user, we do another query to get the post. So we have query 2, 3, 4. And then again, for each post, we need to do another query to query the comments. And this is exactly what the n+1, or I also like to call it the 1 plus n problem. It's exactly what this is about. We need to do a lot of queries. And the problem here is that we're putting a lot of strain on the database. And this is actually exploding exponentially by the hierarchy, by the number of levels we have in our queries. So if we would, for example, have 10 levels in the query, now we have 3. We have user, post, comments, but we could also have 10 levels. Then it would be n to the power of 10 queries that we need to do. And if n is 10, obviously this doesn't work. Like this doesn't scale at all. and we would just shoot down our database. And the truth is, this naive implementation that I have just been showing you here is very slow. And it's only, I benchmarked it locally. It's a MacBook Pro 15-inch 2018. I benchmarked it, and the truth is it can only handle 2.5 requests per second, which is nothing. So that would mean if we have in our live system 3 concurrent requests from the users, we're already at capacity. That's obviously not what we want. So this is very slow, and let's optimize this now. And in order to optimize this, I will show you, first of all, just without doing any magic, without doing any work, how the same resolvers with the same GraphQL server will look like if we use Prisma. So again, we have exactly the same GraphQL server around this, the same type system, etc. But we now, instead of using SQL, we implement the resolvers using Prisma. And again, we first get the all the users that we need. Then we get the post for the users. For each user, we request that user and we get the posts. Yeah? And again, the same deal here. We get the comments for each post. And this is already much more readable, as you can see. This is type safe. That means if I, for example, have a typo and I call it were instead of where, the compiler directly helps us and tells us, did you mean to write where? Obviously, this is one of the main benefits of Prisma. And obviously, this type safety you don't get in SQL. Nothing is happening if I just remove a random character here. And again, we didn't do anything special here. We just replaced the SQL code with Prisma client code. And as you see, it's much more readable and also much more flexible. We can easily put another chain behind that, and it gives us the data that we need. And with the chain, I mean, we can say, give me the user, and then .post, we can have this chaining API to give back the posts for that particular user. So, okay, so how can we now fix this problem? We now are aware that this is very slow, and we would like to get rid of this, and we would like to optimize this now. How can we make that happen? And in order to try to optimize it, we first need to understand what is even happening under the hood. And what is happening is, this is just pseudocode. This is not the real code, but this is just here to illustrate to you what's going on. So again, we're first getting all the users. Then we're looping through all the users and fetch the posts for all the users. And we do a promise.all, await promise.all. That's a very important ingredient, the promise all. We will later come back to it. And again, we now here get all the posts. And once we have all the posts, we say, okay, for all the posts, loop through the posts with a map, give me all the comments, and again, await promise all, which is nothing else than awaiting for all the promises to be resolved. And if one promise rejects it, the whole thing rejects, the whole thing errors. This is basically what is happening under the hood. And this is basically also, if we now translate that to our graph that we have, this is also how this is now working on our graph here. We say, okay, all the user queries, we basically have a promise all around them. And again, with all the post queries, we have a promise all. And you probably already can guess it. The idea now is to batch all of these very related queries. They basically all look the same. They just query for a different ID, for a different user. We can batch these queries together and optimize them. That's the idea. Now, it would be beautiful if we could hook in exactly in the moment in time when the promise.all is being awaited. Again, here, this point in time here, if we could hook in then and just say, okay, thank you for all the queries. I will now take them and I will squash them together. I will optimize them somehow and send an optimized query to the database instead of sending n queries. We would like to send one query. And what if I told you that process next tick is exactly that? This moment in time when we are awaiting the promise all, when we're waiting for all the user requests, that's exactly when the process next tick kicks in. And you can basically imagine this as if we are basically cutting, like, let's say we have this long stripe of incoming request, request after request on the timeline, left to right. Then you can basically imagine the next tick to basically cut out the piece, the request that we need. And here you already see the actual query that we will do instead. We will use a user ID in query. So instead of requesting 3 different users and getting the posts, which would result in 3 different SQL queries, we are just doing one query, and we say, give me all the posts where the user ID is in this list. And that way we can squash all of these queries together. Again, the post has a column called user ID that points to the user table. And again, the same we can do with all the comments that we want to have for the posts. We can again wait and hook into the next process next tick. In exactly that moment, the GraphQL.js implementation is waiting for all the resolvers to return, to resolve. And we can just say, okay, exactly in that moment, we will kick in, we take all of these queries, we batch them together, and then optimize them into this one query called comments find many. And then we get all the comments that are related to any post in that list of posts. And this is basically it. And earlier I showed you that we could just easily replace the SQL queries with Prisma. But now how can we turn on this magic process next tick optimization thing? And by the way, this magic process next tick optimization thing is also called the data loader pattern. And the data loader pattern has been popularized by Facebook, who also initially came up with GraphQL. So let's check this out, how this would look like. Again, we have this implementation here. We didn't do anything. We didn't write any like process next tick and whatever. We don't even know. We don't even have to know the concept of the data loader. And let's now start this server and let's see what kind of queries are being generated with this server. So again, we have been running our naive implementation. Now we will go for the implementation using the find one in the resolvers. So let's look into that. Yeah, so again, we have the same GraphQL playground here. We execute the query. Okay, let's look into the logs. Okay, and as you see, we don't have like 100 queries, but just a few. And let's look into them. The first query that you see, select, blah, 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 ID, public user, email, name from public user. This is basically just giving us back the user. So by the way, these are all the queries logged by Prisma that Prisma are now is doing under the hood. Then we get the IDs. We need them to do our resolution. Then we already get all the posts. Yeah. Again, we use the ID in trick. This is exactly, and this is not only what we could write in the Prisma client syntax. This is actually directly translating into the SQL syntax with the in operation. So this is something that the database can directly understand. It doesn't have to be back and forth with 500 queries and whatever. This is directly coming back. This is directly something that the SQL database, in our case Postgres, can resolve. And as you see, we just turned like the 100 queries into like, 5 queries. And this already makes things much faster. So the left implementation is able to handle on my machine 2.5 requests per second. The implementation on the right-hand side already can resolve about 12 queries per second, which doesn't sound like a lot. But again, remember, we are requesting 10, 10, 10. That means 1,000 items. and the response JSON is actually 240 kilobytes. So it's already something. It's still not like 12, still not a lot, but again, we already got from 2.5 to 12, which is a huge improvement. And what if I told you that we can even go faster? So the thing with this implementation here is that this is already quite awesome, and this is also the recommended way, by the way. But there is a lot of back and forth between Node.js and Rust. So that means first in Node.js, we do the batching. It's like a hybrid approach. Yeah? We do the batching in Node.js, but we do the optimization in Rust. And why do I suddenly talk about Rust here? In case you are not aware of it, the core query engine for Prisma is written in Rust to make the database interaction very fast. And we have a thin layer of TypeScript on top of that Rust code. And again, this back and forth obviously takes time. And what if I told you we can get rid of that back and forth? And we can. For the people who want to really squeeze out the last bit of performance, we have something, or not we, but actually Ahmed Eliva, someone from our community, implemented a beautiful plugin. This is from the community. It's not something we officially support, but if you're really interested in squeezing out the last bit of performance, then you can have a look into this. And so how does this look like? Again, we have everything is the same. Yeah? Like we use Apollo server, we use Prisma. But what we do now, we directly take the query as it is and pass it in. We transform it into something that Prisma Client understands, and we pass it into Prisma Client. We basically delegate Prisma Client to handle all of this resolution. So instead of basically relying on the GraphQL JS engine, resolving all of this data, we are asking Prisma Client to do this. And for the people who have used Prisma Client before, may know that you can say something like, give me users. And you now can say select, I want, for example, the ID, but I also want to have the posts. Yeah, that is, for example, something I could do here. And now let's look into that. So we say, for example, result is this. We can see here now that the response type of this query is actually typed. And this is exactly what this plugin from Ahmed is doing under the hood. It's taking the GraphQL query and it converts it into this select syntax, how we call it, of the Prisma client, so that Prisma client, and therefore also the query engine, can directly take care of the resolution. And again, this one, we can also just run it for fun. This one also obviously is the same deal as with the others. We can execute this, bam. And let's look into what is happening. And we even have less queries. This one is even more optimized in Prisma in particular. So what we see is what we want to see. We see that only 3 queries are being done. Yeah. Again, we have 3 levels. We say user, post, comments, and we are only doing 3 queries. Again, coming from this that does a select, 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 back to this, which is only 3 queries, is obviously a big improvement. And so how fast is this particular one? This one is able, if you also use a faster GraphQL server, it's able to deal with 50 requests per second. And suddenly, this is something that we can talk about. Yeah. So let's look a little bit more into numbers here. I did some benchmarks. And one interesting thing here is that people oftentimes think, oh no, I need to have a fast server. Express is not fast enough or something like that. Yes, you can use a faster server. For example, the Fastify implementation of GraphQL is a bit faster. But as you see here, with the same setup, it just gives us 10%. It's nice, but doesn't give us that much. The change, however, from going with this very inefficient implementation where we do n+1 queries all the time per level of hierarchy versus doing the data loader optimized approach gives us a lot. And if we now see going from the 2.6 to 50, yeah, we get 50 requests per second there. We get a 20x improvement in speed. And there's no caching yet activated, nothing. This is the same stuff. We just use Prisma and Fastify, which is very easy to use. And now, as you cannot unseen, in the first row, we have this enormous number, 2,725 queries per second. But here I just wanted to mention that oftentimes people completely forget that you can do caching in GraphQL. Caching GraphQL is tricky because you would need a cache probably per resolver and so on. There are tools out there, however, and depending on your use case, caching can really make a lot of sense. Let's say you need to implement something like an Instagram timeline, where you say, okay, it's totally fine if the data is stale for 5 minutes. Then you can cache this data, even in a CDN, and can have it blazing fast. And in this case, I just wanted to show you, this is basically the pure like network overhead, the pure, okay, how fast can we shoot data out? In this particular setup, we can shoot 656 megabytes per second out if the query is cached, if the result is cached. In other words, it will not even hit the database. So this is interesting also to look into. It's a huge topic. You can work with e-tags and whatnot, but just FYI, it's not just solving the N+1 problem. It is the biggest bang for the buck when you have the non-cached version, but caching can also be interesting. All the benchmarks are made, many more benchmarks you can check out on my GitHub, timsuchanek/N+1. And that's basically it. Thanks for your attention.
Tim, thank you so much. That was really insightful.
Yeah, thanks. I hope you enjoyed it.
Yeah, I mean, with GraphQL becoming the thing these days, it seems like we've got a lot in store, right?
Yeah, I mean, a lot is happening there. It's quite exciting to see. I have the feeling every second day there's a new library on the top front page of Hacker News about GraphQL. And also, while GraphQL is already quite old in the JavaScript ecosystem, I have the feeling people are already looking for different approaches sometimes. There's still a lot to solve, and it's still a non-trivial problem to fetch nested data.
Yeah, so maybe you're ready to take some questions?
Yep.
So, I mean, the first question that's coming up is, what is GraphQL JIT? Is JIT just in time? Does that?
Yeah, that's an interesting question. So the GraphQL JIT is actually a project that comes from Zalando, who are in Berlin. And I remember last year we sat down here in Berlin in Mitte. We had lunch with some of the Zalando developers. So for Zalando, the main thing is performance. And so what they wanted is to increase the performance of their GraphQL implementation. And we talked about an approach that we saw in the Python world, where the leading framework called Graphene, they were working on an approach for that. I think it was not called Graphene, that new thing, but the idea was basically that you are completely compiling down a function that is already specialized, so to say, on a specific query. So what you need to be aware of is if you have a GraphQL.js server, you are basically always, let's say 20,000 scalars come back or in a response, you're calling 20,000 functions. And that takes effort. And there are issues in GraphQL.js. And
why are there 20,000 function calls, if I may ask?
So that is the case because the whole idea of GraphQL is that you are tying together multiple data sources, which you cannot trust. In the case of Prisma client, it's different because we know Prisma client is type safe, etc. But in the case of Facebook, for example, who came up with GraphQL, they, for example, said by default, everything is optional. And you have to explicitly say that something is required. So they have the opposite paradigm in that regard. And so for them, it's rather, okay, I cannot trust the data source.
I don't know, maybe it doesn't even return anything. So they actually check for all the data to come back. That's why they check, okay, is it null, this required string? Does the data actually come back? And that's why they need these 20,000 function calls if you have 20,000 scalars. And now the idea was, so we told the Zalando people, hey, maybe you want to look into what they're doing in the Python ecosystem. And actually they did that. They looked into it and came up with this library called GraphQL-JIT. And the idea is the following. They take your GraphQL schema, they take your query, and they turn the query into a little bit something like a prepared statement in database speak. That means the whole query is already passed. And the resolver function is already completely generated. So what they are doing is they're using the new function keyword in JavaScript. You know, in JavaScript, you can do fancy stuff. You can, for example, in runtime, create a new function that can then be instantiated. We're not talking about the eval statement. We're talking about new function. You can in runtime instantiate new code.
So you essentially pass a string, which is like the function, the code for the function
exactly.
definition.
And what GraphQL-JIT is basically doing, it's looking into your data, it's looking into your resolver, and it's in runtime generating this function. And now how is it solving these 20,000 function calls? It's basically, you can also check out the GraphQL-JIT website. They have like an online compiler to see what's happening. But what they're basically doing, they're generating one huge ternary statement. And a ternary statement is faster than a lot of function calls, and that's how they made it fast. Yeah.
Thank you. That was really, really cool to hear. So, I mean, speaking of performance, what are some of the performance improvement suggestions that you would have for a deployment to something like AWS Lambda? I mean, we had a lot of, in the polls, we saw many of the attendees are deploying to AWS and Lambda and function as a service providers, and I mean, all the serverless platforms. And then obviously the question comes up, I mean, whether you're with GraphQL or just vanilla Prisma, what are some of the optimizations that you would do there?
Yeah. So what I talked mostly about in my talk was about within your application, what can you do there? But once you deploy this into production, networking is the main where you get most main bang for the buck. And one common mistake I saw quite often when writing with people in Slack, etc., if the database is in a different region than where your function runs, that already makes a huge difference. What you need to be aware of with Prisma, we are not doing joins. That means if you're giving us a huge nested query, Prisma is never doing any join, but we are, as I said in the talk, doing the data loader pattern. That means we get the first hierarchy back, then we do the join in memory in Rust, do the second level and so on. So that means the distance between your Rust and your, or between Prisma client and your database is really essential here. And the lower the distance, the quicker the queries here. And another thing I have to mention here is that this approach, the big advantage of this is we are not putting too much strain on the database because we are doing the joins in Rust. And this is a pattern that you see bigger companies doing. For example, Facebook is using MySQL, but yeah, they're using MySQL mostly as a key value store. That means they put all the heavy logic into application level, because the application layer you can scale horizontally much easier. And that's an interesting pattern here that we are using. And so the distance between the database and the Lambda function is very important. The other one is what everyone is talking about, cold start. The cold start of a Lambda function is a thing. To start everything and to build the initial database connection takes time. Therefore, we recommend to instantiate your Prisma client outside of the function. Therefore, it is still, the connection is basically still running, even though the Lambda function is frozen. Even though the Lambda function doesn't run, the TCP connection is still there. Database and Prisma think they are still connected, unless there's a keep alive package which invalidates it. But basically, you can reuse connections, if you do that, if you put your Prisma client outside of the function, and that way you will also gain a lot of performance.
do you happen to know how long a container of a function is kept around after a single call? So if I make a call to a serverless function with Prisma, how long is that connection kept alive for before AWS drops it?
That's a tricky question because nobody really knows it. I can post a really interesting comparison link, a benchmark in the channel later. You can look it up because there is a continuous serverless comparison website because there's not only Lambda, obviously there are many approaches, and it highly depends on their intelligent scheduling algorithm basically. So it can be a day. I think a day is roughly the time. If there was no further request to that Lambda function, but it highly depends on their scheduling.
Gotcha. Well, Tim, it's been really wonderful having you speak here. Super insightful talk, and you'll be around in the Slack channel, is that right?
Yes, I will be around, so if you have any more questions, you can ask.
All right, all the best, Tim. Okay,
see ya.
Okay, so we now transition into our lightning talks and showcase. I'll introduce our 4 speakers in the order of the talks. Our first speaker, you may recognize him. His name is Ahmed. And Ahmed is a full stack developer from Egypt working with React, Next.js, Gatsby, GraphQL, and Prisma. Currently, he's working with an American software company to create an online education platform for homeschooling. He contributes and maintains several open source projects, including Prisma-related projects. And Ahmed's talk is a showcase of the Prisma admin React component that is built. So that is it for Ahmed. And then we will have Carmen. Carmen is a fresh computer science and multimedia graduate who recently joined Prisma as a software engineering intern. At Prisma, she focuses on the code editor extensions for VS Code and Sublime Text, streamlining the developer experience. Besides that, she's a horticulture enthusiast and buys at least 3 plants a week. So hopefully she'll be able to share some of those plants in the Slack channel. And Carmen's talk will actually go into the Prisma VS Code extension, which she's worked on extensively recently and added a lot of nice additions to. Then we will have Joel. Joel is a TypeScript developer at Prisma, where he focuses on the TypeScript client for Prisma Client and Migrate. Prior to Prisma, he co-founded FontSelf to help creatives with an easy tool to make fonts. And he's been a Node.js fan since 2012. Joel's talk title is Type Safety Beyond TypeScript. And then lastly, we will have Mark Stammer, Johan. Mark is a full stack developer specialized in creating cross-platform apps for Android, iOS, desktop, and the web. He loves open source and maintains and contributes to several open source projects. He's written some of the community tutorials for the Nest.js integration with Prisma, and his talk title is Accessing Databases with Nest.js in Prisma. So introductions aside, I'm super excited for these lightning talks. It's been lovely getting a lot of the community contributors to prepare these talks, and obviously, so the internal speakers. So without any further delay, I give you the stage, Ahmed.
Welcome to my lightning talk about the Prisma admin React component. My name is Ahmed Eliwa. I live in Egypt and I am a full stack developer. Here is what we will cover. Why do we need this component? We already have Prisma Studio, the content of the package, the requirement of the component, some examples and use cases. Let's start. So, why do we need this component when we have Prisma Studio? There are 2 main differences. First, we can ship it to our client in an admin panel. Second, we can customize every feature in it, like you can customize the style of the components and add or hide actions like create, update, and delete. The component also has some features not in Prisma Studio. It's possible to use the query editor for some fields like the post body field. It comes with a great and intuitive UI with 4 themes. When you select a model, it displays the fields of the related tables. We can perform cascading deletions using Prisma tools delete. Now, let's see what this package contains. The first part is the generator. It contains three functions. First, the build setting schema. This convert your schema.prisma file to schema.json file. This file becomes the source of truth for the tables present in your database. Second, the page generator. This generates a page file like every model in our schema. Third, the GraphQL generator. This generates some GraphQL queries and mutations that you will use in your applications. The second part is the React components. First, the Prisma table component. This component builds dynamic tables with create, update, and delete actions. Second, the setting component. This component allows you to customize the table This component allows you to customize the tables you're liking without having to edit any code. Now let's discuss the requirement of the component. First, we must put this React component inside Apollo provider so it can send queries and mutation to our backend. We also need to put it inside an OAH UI layout component for the styling to work properly. Second, in our backend, we must have this list of the queries and mutations. The setting component require one query, get schema, and two mutation, update model, and update fields to update this schema. Prisma table requires three queries and three mutations. All these queries and mutation can be auto-generated using the Prisma Tools Nexus package. Here is the docs link. Here is an example importing admin Nexus settings from Prisma Tools Nexus, and we export it to be in schema file. Now we back. Let's finish with some example. Here is an online version of the tools for you to try without having to install it. Let's try it together. Here is our settings component. You can switch between models from here, and you can change display name in table and forms from here. You can select how this model will display in a related table from here. You can allow or disallow these actions. Here is we don't have add button when we activate it. So now we have add button, and we can add, we can edit, and when we edit we can connect or disconnect to this relations by here and save. And here how the group model is displaying in this related table. We have here password as unread. If I make it as a read, it will display here, and I can rehead again. I can reorder by drag and drop, and like you see, name first, email, and when we edit, name first, then email. If I back it, it's email and name, and edit, it's email and name. And when we add, also reorder, email first and then name. You can connect here. It's very easy and very nice to customize your tables with UI component. Thank you all. Goodbye.
Hi there, I'm Carmen. I'm a software engineer at Prisma, and I'm going to show you the VS Code extension. So you can find the extension on the marketplace in your extension manager within your IDE. So just search for Prisma and you'll see it listed. It provides support to users for editing and writing the Prisma files. And what's interesting about it is that it's actually built on top of a language server, which is essentially the backend logic for the entire thing to be able to work. So let's start by opening a .prisma file, and you'll see all the features along the way. So first of all, the first feature is autocompletion. So before even typing anything, you can press Control Space and you'll see all the possible suggestions, as well as the documentation for every item. So let's start by creating a generator block. Just call that client, and we'll add a field. Again, we can just use one of the suggestions. In this case, I'm going to use a provider. I'm going to use the built-in one from Prisma Client. So you'll notice that a second feature you can already see, it's syntax highlighting. And this is provided all the time. Also, you can see these red squiggly lines, and this is the linting feature. So it tells you if the schema is invalid and you have to change something. For example, here the URL is missing, so that makes the schema invalid. So let's just fix that by adding a URL. And now I'm gonna create a simple model to show you some other things. So first of all, you can also use autocompletion to help with directives. So for example, here I'm using a function as a default value, in this case, auto increment. And I'm also going to create an enum. These are just some random values to show you some things. All right, so let's move on to a Boolean field, which you can also set the default value for. So for example, we set it just false, and you have two more fields. So one of them is off ready, and the other one is user, which is an optional field. And we'll just create that user right now. Again, I'm just going to add a couple of fields to have something to work with. All right, so now I want to have or display that a single user can have multiple posts. So it's a one-to-many relationship, and I'm gonna represent that using a relation directive. So I'm gonna use the relation and have the offer ID as on the many side of the relation. And I can also list the field reference on the other side of the relation, and if I press Control Space, it shows me all the fields from the corresponding model. In this case, I'm just going to use ID. So another feature is if you want to add a doc comment, for example, you have a great comment here, and you hover over the user in the different model, you'll see the doc comment. This is also possible for an enum, so same thing here. If you have a status enum here with doc comment, you can just hover over and you'll see it listed here. So let's assume we have a bigger schema than that, something like that. And you have a model where you don't know all the fields. What you can do is you can press Control and hover over, and you'll see the whole model. And you can also just right-click and go to definition. It will jump right down. And the very last feature is formatting. So if you have something that's kind of messed up here, you can just right-click, form a document, and everything looks fine again. So that's about it for the new features. If you haven't tried it out, I'd recommend you check it out and give it a try. Thanks.
Welcome to my lightning talk. Let's see what's about type safety beyond TypeScript. And I'm Joel. I live in Berlin, and I'm a TypeScript developer at Prisma. And there are two kinds of type safety. The well-known one, especially in the TypeScript world, is the compile time type safety. And it's really nice. But we'll see that in some cases, runtime type safety will be extremely beneficial. And let's see, for example, when you import data, and I prepared a live demonstration about that. So let's go to VS Code. And here, I put some data in a JSON file, but let's say this is an API from a server, from a third-party server. And well, basically it's typed as any. You could type it a little bit, but yeah. So here we can see an example of compile time type safety. For example, I did a typo because if I run it, I will have the same error, and it will tell me that a story text doesn't exist and will probably be with an underscore here because I prepared the schema already and I did it as the data. And let's take a quick look at the data. So the data is here. It looks right like the schema, but maybe the data is corrupted and you don't know before you import it. And let's try to import it. So I prepared this in TypeScript, but to really show the compile time problem, let's switch to JavaScript because here we only in runtime type safety. We forget about compile time. TypeScript is nice for that, but when you only have JavaScript, you still want data safety. And let's run this example. So here, okay, so it looks like we have a problem. So I'm gonna look around. Here, it looks like we have two problems actually. And the Prisma clients creates this really nice error and explains what's happening. So here, the first problem is that the object ID should be an integer. And we passed a string. So I can pass it as an integer, and this will solve it. And we also have the problem of the story text argument that is wrong. So let's fix both. So this one is fixed, and let's do a pass int and rerun it again. Okay, so it looks like it worked, but it looks like at runtime validation, Prisma client found that the created at value from this API, the date time is not correct. So, like looking at it, it looks like there are underscores in this date time, but is totally not correct. So here I have access to the data. So I can fix it. But yeah, there are many ways to fix it if you don't have access to the data. For here, let's do the simple way. So there's one more runtime validation. Let's run it again. And here we also have, again, one more time, author 137. And so there are many ways to do it again. And an easy way here would be to say it's always a string. We run it again. Now it worked. So you can see that runtime validation is really important when importing data here, for example, because it really helps bringing confidence in your code. And yeah. Thank you for your attention.
Hi everyone, welcome to my lightning talk on accessing databases using Nest.js with Prisma. My name is Marc Stammer-Johann and I'm a freelance software developer from Germany. You can find me on GitHub, Twitter and notiz.dev. Let's get started, and I'm excited to show you how to use Nest.js with Prisma. First, I'd like to show you how to make Prisma client available for dependency injection in Nest.js. Secondly, I'd like to show you how to use Prisma client type-safe CRUD operations to build REST and GraphQL APIs. For this, I prepared a small demo using a Nest application, Prisma client, and SQLite database. To follow along, you can install the Nest CLI and create a new application. Add Prisma to Nest as well. For the demo, I'm going to use the following Prisma schema containing a conference database model. Let's get started with the live demo. You can also find the source code on GitHub. I have prepared a Nest application with Prisma client and SQLite database. I also added some example conference data to the database, which we can query later in REST and GraphQL. The Nest application is exposing currently a GraphQL endpoint with the code first approach and also a REST endpoint. To be able to use the Prisma client in our endpoints, we're going to implement a Prisma service. Let's extend the Prisma service with our Prisma client. If we like, we can configure the Prisma client in the constructor. Also, Prisma allows us to establish a connection to the data source programmatically. We can use the onModule init and onModule destroy lifecycle hook from Nest to do this for us. Here we can see we can connect and disconnect from our data source. Awesome. Now we have the Prisma service available. We can use this now in our controller and resolvers to build REST and GraphQL endpoints. First, we are going to add some new REST endpoints. We are going to add the Prisma service to the constructor. Now we can implement conferences and conference by ID as a REST endpoint. Here we can see the conference model cannot be found yet. What we can do is we can import it from Prisma client. Here we go. Now we can use the Prisma service CRUD operations find many to find all conferences in the database, and also use find one to select or filter the database for a specific ID for the conference. If we save, we can go ahead and open up the conference endpoint in the browser. And as you can see here, now we have all databases created in the browser. Awesome. Now we can also go ahead and add the ID, for example, 2 to just query one conference. Nice. What we can do now is we can do the same in GraphQL. Let's open up our resolver file. We have to inject the Prisma service here as well. Now we can add the same queries as we did in REST. Let's go ahead and do this. What we can do now, again, we are using the Prisma service to use the CRUD operations. Just to show you, we are also able to use other CRUD operations such as count, create, delete, and update from the Prisma client. Nice. Let's change back to find many. Let's rebuild the Nest application, and we can open our example queries here in GraphQL. Let's reload the playground so that we have the latest schema available for conferences and our queries. Great, we can add our queries here and perform our conferences query. As you can see here, we can query all of the conferences from the database. And also we are able to just query one database, one conference. Awesome, this was my live demo from my talk. Thanks for joining in and stay healthy.
Thank you so much, Ahmed, Carmen, Joel, and Mark, for your mind-opening lightning talks. It's really enjoyable. I should mention that while we don't have a live video Q&A for the lightning talks, you can find our great lightning talk speakers in the Prisma Slack channel. You'll be able to spot them with the green label below their profile picture. And feel free to just ask any question that you might have for us on the Prisma Day channel on Slack. Also, a quick reminder that we have the Prisma Day stickers. I've posted the link on the Slack channel. If you have trouble finding it, just hit me up. And I think it's really encouraging to see the focus on developer experience that is expanding through the ecosystem. I think there's really an understanding that the tools that we use to build things really matter and affect the products that we build and the impact that they can have. And of course, the integrations that we see now with different frameworks like Nest.js, as we saw in Mark's talk. We're going to take a break now, and we'll be back at 5:45 Central European time. So feel free to join again the Prisma Slack channel discussion during the break. And if you're at home, perhaps grab a snack, drink, or stretch a bit. I'll also share a short yoga chair video, which you can use to stretch out a bit. I know it's a long day. And if that's your cup of tea, enjoy it. I also invite you to participate in the polls as you've participated before, or for the ones who've just joined recently. You'll see a QR code on the break screen, which you can use to join the polls. I'll also share the link if needed. And to those joining just now, we also announced today our new data guide website. So check that out on dataguide.prisma.io. It's a really extensive resource website for how to choose databases and a lot of information about the underpinnings of databases and working with databases and all of those considerations from a very sort of holistic view. So we'll be back at 5:45 and enjoy the break. Welcome back. If you're joining from the Americas, good morning and thank you for joining us. During the break, we ran a poll and we asked you, what are some of the frameworks and libraries that you're most excited about? And many of you expressed interest in Redwood.js, so you've tuned in at the right time. In the first parts of the day, we went on a journey starting from the database layer, and then we looked at data access with Prisma, and also looked at many of the corollary concerns that arise in modern application development, things like frameworks and also developer experience. This part of Prisma Day will really focus on frameworks. And before we get into this part, I'd like to go back in time once again, as I did in the beginning. The Node.js project is about 10 years, is just over 10 years old now. And in that time, it has proven to be a robust and flexible runtime for many applications. It's used by large corporations and indie developers alike. And in that time also, GitHub's rising popularity facilitated the growth of an ever-growing expanding ecosystem of projects and communities. The universality of JavaScript with browsers and Node.js has meant that JavaScript now runs on almost every possible digital device that you can think of, from your computer to your mobile phone, all the way to your smart TV. This reminds me a bit of Atwood's law from 2007. To those of you not familiar, Jeff Atwood is the co-founder of Stack Overflow and a long-time tech writer. And in 2007, he sort of coined this Atwood law, in which he said that any application that can be written in JavaScript will eventually be written in JavaScript. And I think we all know that Node.js can be a double-edged sword. It has a lot of positives and it has a lot of controversial aspects. For example, the lack of conventions and the rapid expansion has meant that there's no single way to do things. So for every possible problem that you're faced with, there's many solutions out there. Many of you may be familiar with JavaScript fatigue as a term that used to describe the difficulty of keeping up with the change in the ecosystem. Nonetheless, we're now in 2020. Despite everything that is happening, there's a lot of promise coming, and we'll get a glimpse of that in the upcoming talks. So in this part, we'll get the opportunity to look at this new wave of frameworks that aim to alleviate many of the pains that developers have experienced with Node.js. And I'm absolutely thrilled about the upcoming talks. So on that note, I'm really honored to invite Tom Preston Werner, which many of you may know already. Tom Preston Werner is a software developer, inventor, entrepreneur living and working in San Francisco. He's currently the co-founder and chief product officer of Chatterbug, the best way to learn a foreign language online. He's also building Redwood.js, a full stack JavaScript web framework for the Jamstack. Prior to these, Tom co-founded GitHub in 2008, where he served as the CEO and helped grow it into the world's most popular code collaboration tool. On the side, Tom is an angel investor and philanthropist with an investment thesis focused on fighting climate change. In his spare time, Tom enjoys flying helicopters, snowboarding, and chasing his 3 young children around the house while making dinosaur noises. So without any further delay, I give the stage to you, Tom.
Hello, today we're going to learn about Redwood.js. I'm Tom Preston Werner. You can find me online at Mojambo on GitHub and Twitter. You might know me best as the creator, co-founder, and CEO of GitHub. I did that for many years. And now I'm working on another startup called Chatterbug, the best place to learn a foreign language online. You may also know me as a creator of such projects as Jekyll, Semantic Versioning, Toml, and Gravatar. Now today, I'm going to talk to you about a new project I'm working on, and that's called Redwood.js. So what is Redwood.js? Well, the easiest way to say it is that Redwood.js is bringing full stack to the Jamstack. So what does that mean? Well, what I'm going to do is show you the code and how a web application built using Redwood comes together. And as I show you the code, I'll explain how it fits together. The first thing I'm going to do is pull down a repository online that lives at github.com/redwoodjs/example-to-do. It's an implementation of a simple to-do application with Redwood.js. And down here, you can see the install instructions. So I've already pulled that down locally, and I've already run yarn in order to get everything installed for it. So the next step is going to be to get the database set up. And I'm going to use yarn redwood db up in order to do that. That's going to use Prisma to migrate the database and get me going. And the next thing I'm going to do is run yarn redwood. I can just type RW for short, yarn redwood dev, and that's going to start both sides of a Redwood application. Redwood has 2 sides, an API side that is an implementation of a GraphQL API, and a web side that is a React client that then can be distributed via a CDN or something like Netlify. So the idea here is that you should be able to deploy a Redwood application using Netlify by just pushing to your GitHub repository and let Netlify or other similar providers take over and do all of the rest. So here I have this up and running. So I'm going to switch to localhost 8910. And now I have my to-do application set up and running. So let's say I want to go shopping for some groceries and I want to buy some milk and some cheese and some eggs. I can add those. I can check them on and off. And this is all the front end, the React client front end, written using Redwood.js, communicating to the GraphQL API via GraphQL to do all of this. Now, the reason that we're using GraphQL to communicate between the front end and the back end is that we envision a future where your application might have more than just a web application front end. So you might start that way, but in the future, if you want to create a mobile application, you're probably going to use GraphQL. And in that case, you would prefer to have just built a GraphQL API that you can already consume, that is already the main effort of your business logic, instead of having written it in something like Rails, where you've done things in the Rails way, and now you decide that you have to add an additional GraphQL API on after the fact. And that's a bunch of additional work that you now have to do. If you start with GraphQL, you're preparing yourself for the future. So let's look at the code for how this works. Over here in my editor, I'll start on the API side, and that lives in an API directory. We use a monorepo approach here. There's actually two node projects, an API project that's going to be deployed to a server or a Lambda. So with Netlify, Netlify can deploy your GraphQL API to AWS Lambdas for you. And then the front end, which is a statically deliverable React client. So on the back end, we can start by looking at the Prisma schema. So we use Prisma as the way to demonstrate how to connect your backend to the database itself, right? So we use Prisma 2. It's been super amazing. It makes it so easy. When we started working on Redwood more than a year ago, the landscape was a lot different when it comes to query builders or ORMs. And we were looking for something that felt right, that felt amazing. And there just wasn't anything out there that we could find. And then we came across Prisma. And coming from a Rails background, working with Active Record, which is a tremendous accomplishment, everything in the JavaScript world and the TypeScript world felt mediocre. But the way that Prisma approaches the world, we felt was really nice. The way that you create relationships between tables, and just the ease of setup and the built-in migrations, all of that's available to us. And so we've integrated that and made it a fundamental part of what a Redwood.js app is. So let's look at the model here. So in the Prisma schema file, we have a to-do model, and it has an ID that's just going to be the default auto-incrementing integer ID. We have a body that's a string. We'll make sure it's unique. And then we have the status that's a string. It will default to off, and it can have other states. So let's now look at how the GraphQL part comes together. So we look in API source GraphQL todos.sdl.js. SDL is the schema definition language for GraphQL. So you're just very simply writing the SDL directly for your GraphQL. It makes it really easy to understand what your GraphQL API looks like. So we have a to-do type with those same fields, and we have a query, a to-dos query, that'll return a list of to-dos, and then we have a few mutations: create to-do, update to-do status, and rename to-do. And I want you to pay attention to these names: to-dos, create to-do, update to-do status, and rename to-do. Because when it comes to the implementation of these GraphQL, of this GraphQL API, that happens in this services to-dos.js file. And you'll see that we're just creating functions that have the same names and exporting them. And Redwood.js is going to map your GraphQL SDL to these functions directly. So instead of creating a resolver map like you would normally with Apollo, which is what we use, Apollo server, we'll do that work for you. And it also makes these functions more reusable. You can see that these are just functions that take normal sets of parameters and then will return promises in this case. Apollo knows how to consume those promises, but this means that you can call these from other parts of your backend. And the way that we organize the backend is through services. All right? And a service, when I say service, I don't mean a microservice or anything that's running separately. It's all running together in the same runtime. These are just chunks of your backend that you're creating as a sort of API, an internal API. And so services can call into other services, and each of those services would be responsible for a set of tables. And that's how the backend works, the API. So let's take a look at the front end real quick. Everything starts in source routes. We've written our own router we call Redwood Router. And it's a single place for all your routes to exist. It makes it really easy to trace the path of where your code lives. And it's just mapping URLs to components that end up being your pages. And then you can give them a name, which is useful in the named route functions that I'll show you in a little bit. We can look at a page like the home page here and see it's just a normal React component. We're using styled components here. And we're doing some data fetching with Redwood cells. And I'll show you how to do data fetching with a Redwood cell shortly. And then just putting these things on the page. So let's get into adding a little bit of functionality. So the first thing that I want to do is create a new page. So I'm going to create a new page for you here. I'm going to open up the routes file so you can see what it does. And in Redwood, we have a bunch of generators that make it really easy to do a lot of things. One of those things that you can do is create a page. So I'm going to down here type yarn redwood generate page, and I'm just going to call it a count. I'm going to create a page that's going to tell me how many to-do items I have. So I'm just going to call it count. And now you'll see that I get this count route in here, and it's named count. And if I go to that page /count in my browser, then you'll see that that page exists, and I can open up that page here, and you'll see that these are the same. So that's where my page is going to live. And now let's work on the GraphQL implementation for that. So I'm going to start in my SDL, and to define this, this is going to be a count, but I'm going to call the query to-dos count just to make sure it has its own namespace. And it's going to return an integer, and it's always going to return an integer. Another nice thing that comes with Redwood via Prisma is a GraphQL inspector. So I can come in here and I can run this query now, and I'll see in the docs here that I already have this available, but there's no implementation yet. So what I'm going to do is implement it, and that's as easy as going into the services file for to-dos and implementing a count. So I'll do that here. I'm going to export const to-dos count, and that's going to be a function with no parameters that's going to return the count of records in the database. So I have that saved, and now I'm going to come over here and I'm going to run to-dos count as a query, and we'll see that we get the result. So that's how easy it was. Just a few keystrokes, I've been able to implement that whole GraphQL backend. That's a lot of what Redwood is doing for you. So let's continue with that. And on the front end here, I'm going to use a cell to do the fetching. And I'll show you what a cell is. So yarn redwood generate cell. And I'm just going to call it the to-dos count cell. And this is going to generate for me this to-dos count cell right here. A cell is a declarative way to do your data fetching in Redwood. So it's going to guess what query you want. In our case, this is just a scalar query, so it'll look like that. And what we're doing for you is running this query and then passing the results or the different lifecycle methods, and you just declare what these components look like. So you have a loading state, an empty state, a failure state, and then your success state. So when you're writing your success component, you can really just focus on it being the correct results from this query. So this should be all we need to do. Whatever you call here is going to be passed into here, and it's just going to be JSON stringified and output. So let's now use that cell in our count page. So we'll do import to-dos count cell from source components to-dos count cell, and then we'll be able to use it here. To-dos count cell. And if we come back to this page and we save this, then we'll see that that loads, and indeed it is pulling that data from the GraphQL API, and it would have shown a loading there if it had taken longer to load. So that's front to back, end to end, how you would create a simple page in Redwood. So, okay, that's cool, but that's pretty simple. So let's try to do something a little bit more challenging. So what I want to do now is implement a page that's going to list out the contents of each of these to-dos, kind of a single to-do view page. So in order to do that, I'm going to start on my backend here with the GraphQL, and I'm going to say, what do I need? I want to have a query that's going to return just a single to-do, and it's going to take an ID, and that's going to be of an integer type, and that's going to return a to-do item, and possibly that to-do item is null. And then I'll work on the implementation here, and that's going to be a to-do. So I'll do export const to-do, and that's going to take an ID parameter and return a db to-do find one. I'm using Prisma here. It makes this whole thing really easy. And I'll give it a where clause, and that's just going to say ID is ID. So we can come over to our playground here, and let's run a to-dos query with the ID being 1, and I'll get back the ID and the body. And we'll run that. And now we can see here that we have the first item that we entered, milk. Okay, great. So the GraphQL side is implemented. And now on the web side, I'm going to need a page. So I'll come back and I will yarn redwood generate page, and I'm going to just call this the to-do page. So now I have my to-do here, and if I load that up in my browser, then I can see that that page exists. And what do I need to do here? Really what I need to do is pass in a parameter. And so this, I'll show you how to do route parameters with Redwood. Use curly braces. You give it a name for whatever's going to be in this part of the URL. And then you can even tell it what type. And because this is going to be the integer of the ID, then I can specify that I want it to be an int. And that will not only make sure that I'm only matching things with integer IDs in this part here, but it will actually parse this and turn it into an integer in my code, making that all ready for me. So I'll make sure this page is saved. And now you can see that this page is not found because it no longer matches this route. There's no ID on it. But if I get it a /1, now it matches again and ID becomes available. And that becomes available in my to-do page. And that's just going to be passed in to the component as a prop. So I can say that I want to receive an ID prop, and now I can use that in my component. So in order to get data from the backend, I need to do some data fetching, which means I need a cell. So I can say yarn redwood generate cell, and this one's just going to be called to-do. So it'll be called the to-do cell. And the to-do cell looks like this. We need to be able to pass in the parameters here. And so I'll give this query a name, and I'll say the ID is going to be an integer. This is just the same as in the SDL. And then in the query itself, I'll say that the ID is that ID that's being passed in. And I'm going to want back the ID, the body, and we'll say the status. So now this is my query, and whatever this is called will be the same name of the variable that's received here, and we'll just stringify that when it comes out. Redwood's going to do the mapping for you of whatever comes in here. It's going to put the parameters from the props that you send in to this cell that is representing itself as a normal React component. We do that for you with a higher order component, but that all happens behind the scenes. And so I just call to-do cell like a normal cell. So on my to-do page, I will import to-do cell from source components, to-do cell. And you can always reference things just from the source directory anywhere in a Redwood app. It just makes it really easy to know where things are and how to get them. So to-do cell. And then I can use that right here. I'm going to say to-do cell, and it now takes a parameter. It takes that ID parameter. So ID is going to be ID, right? That's just what's coming in here. And we'll close that, and we'll save that. And here we go. There we go. Now it's reaching out to the backend. It's asking for it to execute that query, the to-do query that I specified. It's getting back the data for that query. Now the next thing that I want to do is link up the items on the home page so that I can click them and go to that to-do page. Okay. So we'll start with the to-do item, which is each one of these things is represented by this to-do item component. And in here, I'm going to need a few things from the router. So I'm going to import link and routes from Redwood.js router. And then right here is where the body is. So this is the line that prints these out. And I'm going to replace the body with something that's going to generate a link. So I'm just going to create a new function called to-do-link. And it's going to take an ID and a body. And it's going to return a link. And the way that we create links in a Redwood application, we say link to, and then we can use this routes from the router. And then we can use the name. We just use the name of the route, which is why we give the routes names. And then these are actually functions. And I can pass in the ID that I want to use to fill in that piece of the route parameter, and it will generate the URL for me, so I don't have to hard code the URLs. And the body of it is just going to be body. And so now I should be able to, down here, make a call to to-do link and pass it the ID and the body that are coming from up here, ID and body that are being passed in already. So I'll save that, and now these are linked up, and if I click on one of them, then it goes to my to-do page. So there's a little bit of how you do the routes. Okay, that's all well and good. Let's do something even harder. So next, I want to add authentication, right? Because my application right now is open to the world. Anyone can come on here and be like, hey, Tom, you should buy some Twinkies, right? But I don't want anyone in the world to be able to do that. I want to have to log in so that I only have access to this. So let's add auth. And in the Redwood way, we've made this super easy. So I'm going to start with the generator, of course. So I can type yarn redwood generate auth. And right now we support Netlify identity, auth0, magic links, and we have some Firebase support that is sort of half done. I should mention that Redwood is in alpha, maybe nearly beta status. We're hoping to have a 1.0 out before the end of the year, but this is all still very much in progress. So here we go, yarn redwood generate auth. I'm going to choose Netlify to make my life really easy, use Netlify identity. And I'm going to run this. This will take a minute to run, and what it's doing is pulling down some packages and adding bits of code here and there in my application that I'm going to be able to use to do my authentication. And that's going to provide me everything I need to do that. And you can see where it does this actually is in the index.js page, and it's added this auth provider that just says it's Netlify. But we do all the hard work for you. And so that all I need to do is have a place to actually log in. So I'm going to create a page to do that. I'm just going to call it yarn redwood generate page. I'm going to call it a login page. And so now if I go to /login, I have a page here. I'll open the page. And in order to do the authentication now, I have access to Redwood.js auth and a use auth function. So to get that, I'm going to import use auth from Redwood.js auth. And then in my component, this is a simple hook. So I'm going to use it like a hook here. So I'm going to say const. I'm going to destructure some stuff, and that's going to be coming out of use auth. Okay. And then the things that I can get out of there are a login function, a log out function. I can get the current user, if there is one, and I can get an is authenticated Boolean that I can use. Okay, great. So I have those. And now I can just create a simple button. So button on click equals log in. So I want a login button, and that'll just be called log in. And I want a log out button. That'll be called log out. Okay. So I can get those on the page, but really I want to know if I'm logged in or not. So let's use is authenticated. And when I'm authenticated, I'm going to print out the current user.email. That's a field in there. And if I'm not authenticated, then I'm going to just say logged out. Okay. So here we go. I've saved that. And indeed, I am logged out. Now, the magic here is that these buttons are hooked up to all of the guts of Netlify Identity and the Netlify Identity widget. So all I need to do is click login, and I'm fully implemented. Everything is connected for me. And I already have this set up in a local development. You need to connect it to your URL here that you get out of the Netlify application. I've already done that. And so I'm just going to log in. And now you'll see my email address. So I've successfully logged in. I am authenticated. Okay, that's cool, right? I have a user. I can tell who that user is, but now I need to secure my application. So the problem is if I log out again and I go back to the home page, I'm still able to see this, to see the to-do app, right? I want to secure this. So I'm going to go to my routes file, and I'm going to use a component called private, and I'm going to wrap all of the routes that I want to be private. So that's everything from here, the to-do page, the count page, and the home page. The not found page will be outside of what's authenticated, and the login page obviously needs to be outside of what's authenticated. And then I'm going to say the unauthenticated, when I'm not authenticated and I go to any of these pages, I want that to redirect to the login page, right? I'm just using the same name that's right here. And now if I save that, you can see it redirected me over to the login page. Okay, and I'll show you that again. If I go to the root page, it redirects me over. So now I'm going to log in and get an authenticated user here. And now when I go back to the home page, there we go. Now I have access. Now we also have some things on the back end that make this really easy too, because I can still run the GraphQL query. This is still going to work. I can still run this, right? But I need this to work on the back end as well. And so we've added for you in the API side this lib auth directory here, and you get access to this require auth function. So in your services implementation, then you can simply import require auth from source lib auth. And then in any of your functions here, you could just make a simple call to use require auth, and that will check that you have an authenticated user. I'm out of time, so I'm not going to show you exactly how to do that, but you would just add it right here, and that would secure the backend. So that's what I wanted to show you today. And if you would like to learn more about Redwood and everything that we can do, you can go to redwoodjs.com. We have a forum, we have a chat, we have a newsletter, we have a really extensive tutorial, we have documentation, cookbook recipes, everything that you need to get started with Redwood. And I should say that if you want free stickers, then we will send you anywhere in the world 100% for free a set of 3 stickers. All you have to do is go to redwoodjs.com/stickers and fill out the form. Thanks so much for watching.
Thank you, Tom. That was I really enjoyed that. It was very approachable and a thoughtful talk. And exciting times for Redwood.js.
Great, thanks.
Also, want to shout out to the beautiful docs. It's been really a pleasure. Both the content and the design and just finding my way around it was really a delight. Are you ready to take some questions?
Yeah, let's go.
Okay, so I think the first question that comes to mind is when can we expect Redwood.js to be production ready?
Well, we are targeting sometime before the end of the year for a 1.0 release. There's still a few things that are really important to us that we want to get in there. So we're working on testing right now. Testing is going really well with Jest integration. Storybook integration is about to go in, and that'll take some time to integrate all the mocking and the various things that we want to do to make it work with the little bits of magic that Redwood introduces. We have pre-rendering that we need to get in there still. Those are the bulk of the things. And that's mainly what we want to get in there, and some additional work on authentication for role-based authentication. That's slated to go in before 1.0. And so we should be able to get all that done before the end of the year, hopefully well before the end of the year, but we'll see how quickly we can make it happen.
Yeah, and mind sharing more about the current state of TypeScript support?
Yeah, so we started the project writing it in JavaScript, and we've now ported most of it over to TypeScript. And so that's also pre 1.0. We'll have full end-to-end TypeScript on everything. The entire framework itself will be written in TypeScript. And going forward, everything will be TypeScript native. And then things like the generators already have TypeScript support, and then they'll compile down to JavaScript for the generators if you choose to have JavaScript. So you'll be able to choose up front, I want to do Redwood in TypeScript, or I want to do Redwood in JavaScript, and then the rest of the framework will take its cues from that.
Oh, great. And how's that transition been, sort of having started working, building it in JavaScript? Has that sort of been an easy journey?
Yeah, it's none of us were particularly specialized in TypeScript, so that's been a bit of a learning experience for all of us. And for anyone who's learned TypeScript, I'm sure it takes a little bit of time to get up to speed with conventions and how you do things. But we have some really amazing community members that have pitched in a lot and helped us do that. So the transition is actually going really well, and we're all learning things about it. So I'm very happy with how that's going.
And from what I saw, you also have a very active Discord where a lot of the contributors are sort of engaging and contributing and having discussions. So that's all.
So we started with just a discourse forum, and that's where we do our main discussions. That's where we really want to have a searchable, open catalog. We host it ourselves, so there's not any third-party privacy issues. That's sort of what we consider to be the first-class main place that we have real work discussions. And then the Discord server for chat is hosted, and so for people that are comfortable with that from a privacy perspective and just want to have sort of chat with other people that are working on Redwood and spitball ideas, then that's a great place for those. We have both of those very active.
Great. And so Redwood is often advertised as a framework for the Jamstack. And that sort of begs a lot of questions around, is it specific to Jamstack, or can you deploy it using different deployment models? Mind chiming in on that?
So the whole reason that Redwood really exists is a desire of mine to create a full stack web framework that would work deploying to something like Netlify and using the Jamstack methodology. So that's really what it's optimized for. But there's nothing about the architecture that would prevent you from running it on your own servers, on bare metal, anywhere that you can run Node. You could run the API backend. You could use AWS directly to put the front end on a CDN. Like, you can do all of those things. And right now we're working on additional deployments to Vercel, as well as directly to AWS, to Google Compute Cloud, and using a whole variety of different ways, as well as making it really easy to set up your own deployment scripts so that you can do whatever custom thing that you want to do, right? So we start with the Jamstack deployment methodology, but now we're making these other ways work. It's just Node, right? So anywhere that Node works, you can kind of make this thing work.
And I mean, obviously Redwood uses Prisma under the hood. What are some of the features that you're most waiting for from Prisma?
Yeah, I mentioned them in the chat. There's a couple of things that we really want. We want dynamic providers for the database type, because in the tutorial, we ask you to use SQLite, and then we want you to change to Postgres when you deploy. And so making it really easy to navigate that is part of what we want to do. There's some things around the types of the column types. There's some limitations on string right now that we need to be able to use. And really looking forward to migrations reaching a production ready state. That's such a huge part of a really good full stack development flow. And I think Prisma migrations are amazing, the direction that they're going. And I really look forward to seeing those mature.
Great. So we have one question coming in from the audience. Does Redwood include a way to share code between the API and web?
Yeah, so you could just put code that you want to share between the two in a directory that sits at the same level as the web and API, and then import those directly. We don't have a sort of a convenience right now. You can import everything on both of the sides directly from the source directory. We should probably consider adding a way to add those kind of external bits to both sides. But again, because it's a mono repo, all the code lives together. There's no reason that either of those sides wouldn't be able to reach out and include any of those things. You can also, if you have a library of code in a NPM package of some sort, you can certainly import them that way and use them across both sides. But I think the question is referring to the former, and it's trivial to do. You have to refer to them by relative path currently, but bringing up that question makes me feel like we should make a convenience helper for that.
Cool. Well, do you have anything else you want to mention before we wrap up the Q&A?
I just say we are really happy for anyone who's interested in this to come join in the discussion, help us build it, or just report issues. We're very happy to receive them. Pull requests, we have a growing community of people. We have more than 60 some contributors now that are helping out, some of them very active. And it's just been a whole lot of fun. And we would love to have more voices in the mix. And so please come to the website, grab your free stickers by going to the sticker URL, and we'll ship them to you anywhere in the world.
I've got mine on the laptop.
Oh, amazing. Amazing. So yeah, we're just so happy to be doing this. We want to save developers time. This is what I love doing. I love building stuff. I love helping people out from a development perspective. So come join us.
Well, Tom, thank you so much for joining us today. Thank you for the talk. It's been a pleasure. Hope you have a lovely day.
Thank you. Thanks for having me.
All right. Okay. So we just finished our part on Redwood.js, and we will now move on to another full stack framework called Blitz.js that also uses Prisma under the hood. The creator behind Blitz.js is Brandon Beyer. He's currently a full-time maintainer of Blitz and supports himself with part-time consulting on the side. He's currently living in Thailand as a digital nomad. And outside of Blitz, his other passion is flying airplanes and helicopters. So it seems like there's a bit of a corollary there amongst some of the framework developers using Prisma. So without any further delay, I give you Brandon.
Hello, Prisma Day. Let's talk about Blitz.js, the new full stack framework for React. Before I get into it, I'll give a quick overview of what Blitz is. Blitz is built on Next.js and Prisma 2. Blitz is inspired by Ruby on Rails and provides a lot of the developer experience and productivity that Rails provides. And lastly, Blitz has a new full stack data layer that has never been seen before, and it's super awesome. I'll talk about it in a few moments. But first, why a new framework? We already have Next.js, which is a framework for React, and now Blitz is a framework for a framework? What is happening here? What's going on? Well, the reality is that building a full stack application today is too hard and too complex. So many people are yearning for a simpler, easier way to build full stack apps, and Blitz is the answer to that. Additionally, there's this process that happens in all areas of technology called bundling and unbundling. So an example of bundling was Ruby on Rails. It took many different libraries and things and integrated them together, bundled them together into a really nice, easy to use framework. And then fast forward to React, and that was an example of unbundling, because React was hyper focused on just one specific area of your application. And we've had this explosion of tiny focused libraries and JavaScript. And that's been amazing for experimentation, and we've made so much progress. But now it's time for another bundling, and that's what Blitz is providing. So I'm going to talk about the foundational principles of Blitz. Full stack and monolithic, API not required, convention over configuration, loose opinions, easy to start, easy to scale, stability, and community over code. So full stack and monolithic, what does this mean? It means you only have one thing to build and one thing to deploy. There's only one thing to reason about. And so a monolith means that it's much easier and faster to develop your application than any other decoupled architecture, such as microservices, or even just a backend API and a front end that are separated. A monolith is so much faster and easier. Now, there are some drawbacks, especially with traditional monoliths, but a modern monolith scales much better. Scaling is one of the most common issues with the monolith, but serverless makes a big difference here, and we'll talk about this a little bit more. Secondly, the vast majority of apps don't really need to scale very much. So for example, in the United States, 99% of all businesses have less than 100 employees. And then something around 95% have less than 50 employees. So this means the very, very large majority of us are small companies serving small companies. Granted, some of these small companies can serve millions of users, but the reality is, the vast majority have way less than 1 million users. And so they don't need to scale very much. Most of us in the world are not building Silicon Valley unicorns. So this means that we need a framework that's optimized for this 99% use case, not optimized just for the Silicon Valley unicorn that needs to scale to billions of users. API not required. Now, what is this? Because traditionally, an API is required for any type of single-page app, right? You have to have a backend API in order to get your data to the front end. But the problem is APIs add complexity and they slow you down even more than you might realize. So how Blitz got started was a little over 3 months ago, I had a call with a friend of mine that's deeply into the Ruby on Rails ecosystem. And we were sparring back and forth about the differences and trade-offs between Ruby on Rails and React apps. We were talking about different productivity benefits, technology benefits. And after we finished that call, I was greatly vexed with the simplicity of Ruby on Rails. It's so simple because there's not this entire API component in the middle of your app. And for example, you can even access your database directly in your view. It's not recommended, but you can do it because it's so simple. So I was thinking after that call that, I think now is the time for Ruby on Rails for React and JavaScript, because we have Next.js, which is an amazing framework that so many people love. And especially within the last year, they've added a lot of great new features. And then secondly, Prisma 2 is now available. And that's like one of the last missing pieces for a nice full stack developer experience, because accessing the database is like one of the hardest problems people have. And so it needs to be really easy and nice. And Prisma 2 is doing a great job here. All right, now how does this actually work, right? Because how can we just get rid of the API for React app and still have client-side rendering? That sounds ridiculous. But how we do it is we abstract the API into a compile step. This allows you to import your server code directly into your front-end React components, and it just works. So how you write your server code in Blitz apps are Blitz queries and mutations. These are plain asynchronous JavaScript functions that always run on the server. So there's no GraphQL here. It's just we just use the same naming. But then, of course, you can add your own API if you need. So if you have advanced use cases, if you have a third-party API already, of course, you can still use that just like you always have. You can add custom API routes. So just like with Next.js, you can build out a REST API or GraphQL API, like all of that's up to you. And then additionally, the Blitz queries and mutations, you can also reuse those by third parties. So you can add token authentication, which will be easy for you to do. And then you can use queries and mutations without any API, because it's automatically generated for you. So let's look at the architecture here. Along the top, we have client code, so code that runs on the client. On the bottom, we have code that runs on the server. The purple boxes are React pages. On the left, we have a server-side rendered page, which has code executing on both the client and the server. On the top right, we have a page that is client-side rendered only. Okay, there's no SSR here. And then at the bottom right, we have two green boxes, which is a Blitz query and a Blitz mutation, get listing and update listing. So if you have an SSR page, then you can just import that function directly, and it's just a direct function call. It doesn't actually make an API call in that case. But when you access a query or mutation from your client-side rendered page, then this magical gray box appears at build time because of Blitz. It's an auto-generated JSON API. It exposes your queries and mutations at a certain URL, and then that direct function import is swapped out with an API call. But when you're building your app, you don't have to know that. So let's look at what the code looks like. Here is the get listing query that always runs on the server. So the first line, we import the database from a database file. So this is a instantiated database client, and it's Prisma 2, of course, along with the types here. So this is one thing that's super nice about Prisma 2 is we get these automatically generated types from your database, and then we can use those types as to type the input of this query. And you can see we export its asynchronous function. Inside that function, we access the database directly and return that result. Now this is very simple, of course, but you would add authentication, or not authentication, sorry, authorization here, maybe any other kind of processing or fire off background jobs or events. So all of that would happen here. So pretty simple. Now, how do we use this query in your app, right? So here is a React component that's using that query. So we import a couple hooks from Blitz, and then on the second line, we import that get listing function from that file. So this is a direct function import. And inside this component, we get the listing ID route parameter, and then we pass the get listing query into the use query hook along with the arguments for that query. And then that returns the listing object, and we can use that in our component. So this is it. This is all you have to do to get data all the way from your database to your front end. No GraphQL, no GraphQL queries, schemas, no REST, no fetching, nothing. You just import it and use it. It's so awesome and so fast and easy. Now, this use query hook is provided by, it's built on React Query. So you get all the amazing things that React Query provides, like caching, automatic cache and validation when you come back to a page, polling, etc. So super nice. All right, convention over configuration. Convention over configuration means that everything works by default without configuring. So a lot of the menial decisions, boring decisions are done for you. These are like decisions that you have to make for every single app. And a lot of them, you end up making the same decision over and over, or it just doesn't matter. And so we do that for you. And we also do all the boring work for you. Like, like you can spend up to a week setting up a new application, and all of that is done for you. Yes, Lint is configured, Husky, Git hooks, all of these different like integration of all these things together. We do that for you. So this doesn't mean that there's no configuration. It means that configuration is optional. So I already talked briefly about the new app setup. This is one area where the convention is pretty noticeable. And Blitz is database agnostic, so it will work with any database, any ORM, any database client. But Prisma 2 is the default because we think it's the best for most people. The other area where you will see convention over configuration is with code organization and scaffolding. So out of the box, we have a really nice file structure already set up for you. And we have these really awesome code generator tools that can generate working code for like an entire model. So you can run Blitz generate all, say, task, and it'll generate the Prisma model. It'll generate the queries, mutations, the pages, everything you need for end-to-end for creating a task, updating a task, deleting a task, and viewing a list of tasks. Now, if you want to go outside the convention, you can. The default scaffolding won't work, but we're adding an ability to we will add the ability to customize the code generator so that you can set up something totally custom if you want to. Moving on to loose opinions. Blitz is opinionated, and it gives you a happy path that is going to be good for most use cases. But Blitz isn't arrogant. It knows that there's not a single magic bullet for every application. And so for many things, many times we don't enforce the conventions or enforce our opinions. For example, the file structure, we have a default file structure for you, but the only things that we enforce are that pages are in pages because that's how you do your routing. And then queries and mutations are in the corresponding folders because that's how we generate the API. And then also API routes are inside the API folder. But one thing to note here that's different than Next is that you can have a pages folder all in every directory. So you can organize your pages by like the main context, and we'll talk about that in a little bit. But it's, so you have a lot of flexibility here is the point. And when there's not consensus, we give you a choice. So a great example is a styling solution. Nobody in the React community has really agreed on like the best styling here. So what we will do is add a prompt when you're setting up a new app, and we'll show you the most popular styling like libraries or frameworks, and we'll let you choose which one you want, whether it's like style components or Tailwind CSS, etc. And then whichever one you choose, the app will be already set up and configured for that. And so this strikes a good balance between not forcing you to use like something that you don't want to use, but also like, and so it gives you the choice, but then it's also, you don't have to set it up manually, where today you have to configure everything together, set it up yourself. So overall, Blitz is more flexible and has less magic than Ruby on Rails. And I think it strikes a good balance between kind of Ruby on Rails on one extreme and then the Wild West of React development today. All right, easy to start, easy to scale. Now, this is very important for the success of any framework, I think, because at the starting, it has to be easy for everyone to get started. So easy for beginners means that someone new to programming who's just learning HTML, just learning about databases and React and JavaScript, they should not have to learn advanced technologies like GraphQL. That's a total non-starter for them. And so Blitz addresses this very nicely. But on the other hand, it also must be easy to scale, right? Otherwise, it's not going to be good for production applications. And Blitz addresses this. There's a couple aspects to scaling. One is the amount of code that you have and then how that's organized. Blitz addresses this by organizing all your files by domain context. So all your pages, mutations, queries, and components for a certain, say, model, or in more general, a domain context, those are all organized in the same place. And this is the opposite of Ruby on Rails, which organizes files by type. So in Ruby, in Rails, all your models are in one place, and then all your controllers are in a totally separate place, and your views are in even another place. And so it's really hard to find all the code related to a certain thing like billing because it's scattered all around your application. But with Blitz, it's all organized together, so it's really nice. This also makes it easy to reorganize and refactor your file structure because you can drag and drop those domain contexts and folders around, and it just works. Now, code execution is the second way that you have scaling. So this is, a lot of times, this is where a monolith sort of breaks down because you have this entire server that you have to scale the whole thing. And so you have to have multiple instances of that entire server running. And then you have to manage those servers and load balance, and it's annoying. But this is where serverless really saves the day. So with I should have mentioned, you can deploy Blitz to a server or serverless. You have the choice. If you deploy Blitz to a server, you have the same monolith scaling issues. But again, you may not need to scale, and it might be fine. But if you deploy to serverless, then all your queries, mutations, API, endpoints, etc., are all individual serverless functions. And so they scale automatically and independently. And so the whole scaling issue with a monolith basically disappears. So it's super nice. All right, moving on to stability. We all love stability when it comes to our dependencies because we don't like bug fix or breaking changes and bugs in other people's code that we depend on. So we will continue in the footsteps of React and Next.js, which have done a very good job of being stable, not having a lot of breaking changes, not a lot of bugs. And one way we're going to address this is to have some sort of predictable release cycle like Ember. Now, Ember has 4 different release channels. They have Canary, which is like the latest on the master branch. And then they have a beta release channel where the next stable release is in beta for 6 weeks. And so this ensures that there's a minimum period of time for bugs to be worked out and for it to become stable before it's marked as stable. And then the stable release is marked as released every 6 weeks. Lastly, they have a long-term support option, which is released every 6 months. And you get continual bug fixes for that, but you're guaranteed that there's not going to be any type of like breaking chains, and you can just get bug fixes for a long term. So depending on what the needs are for your app, you have this option. So we'd love your input for what you want to see here for Blitz, because it's, this is still up in the air. We will do this whenever we go to 1.0. Lastly, we follow a request for commits process. It's quite informal right now, but we will make it more formal as we grow. And what this is for any like big feature or change that we're going to make to the framework, we open an RFC discussion to outline why we want this change, what the changes are, what the impacts and implications are, and maybe the trade-offs. And this is really great because it gives the community time to review this, to comment, and make sure that whatever need they have is met by that. And it makes for just a really nice, it makes for a healthy community, really, and a framework that meets everybody's needs. Lastly, community over code. This is the most important principle, because people are far more important than anything else. They are more important than code style, than code architecture, etc. People are the most important. We treat every person with dignity and worth. We are all in this together. We all want a framework that makes us productive and is fun to use. We are all more similar than we are different, and so we should bond over our commonalities and not be driven apart by our small differences. We can and should solve problems together. This always makes for better solutions. And this is what community looks like. As we come to the end, let's talk about how you can get involved. Blitz is not backed by a company. And this is a good thing because it means Blitz is a framework by the community for the community. There's not one company that has control over the framework. And anyone can come in and influence the direction of the project. But this also means we need your help. So we invite every single one of you to join and help make Blitz an awesome framework. There's different ways you can contribute. You can contribute via code. We have a lot of open issues that are marked as ready to work on. And we also mark issues as good first issue and good second issue. The good first issues always get picked up really fast, so make sure you watch the repo if you want one of those. Documentation can always be improved. We welcome any improvements there. You can make video courses, blog posts, and anything that helps anyone in any way is always appreciated. Lastly, donations and sponsorships are a great way to support Blitz and ensure that it lasts well over the long term. As an individual, you can sponsor on GitHub or Patreon. If you go to the Blitz repo and go to the top and click on sponsor, you can see the options there. And we also have sponsorship tiers for corporations. So if you're a company and interested in sponsoring us, I would love to talk to you about how that would work. And that's all I have for today. So the best way to get started is go to blitzjs.com. My Twitter handle is flybear, and the Blitz handle is blitz_JS. Thank you so much for your attention today, and I hope you try out Blitz, and I would love to hear your thoughts about it after you try it out. Thank you.
Brandon, thank you so much for the interesting talk. Blitz.js looks really slick. Glad you can join me.
Yeah, great to be here.
You ready for some questions?
Sure am.
Okay, so I mean, we had a lot of questions coming in, and I think the first interesting question that we have is, do you have any plans for authentication support?
Yes, absolutely. So I'm working on that right now, and what we're doing, we're adding a built-in session management layer, which handles all of the cookies and tokens for you. And then, so that's the first piece that we're working on right now. And then the second piece will be, how do you actually verify someone's identity? By default, we will have a code that takes care of all of the password hashing and stuff and storing that locally in your database. So that's the default. Right. And then, of course, we'll also support OAuth and like social logins and all of that.
Oh, okay. So is the plan for that to be something like supporting Auth0 and Firebase type authentication?
Yes.
Okay.
Yes.
I see. And what about React Native integration? Can we expect to see that coming from Blitz.js?
Oh, good question. Yes. So one thing that people are like kind of hesitant about Blitz is like, well, how do you do the mobile apps, right? But we are planning to add React Native support to Blitz so that you get the same, like in quotes, no API experience, where you can import server code directly into React Native code and then have that automatically swapped out for the API, just like with a Blitz web. So we're not for sure totally if we're going to be able to accomplish that yet. Pretty sure we can. But if not, the fallback is to automatically generate a client that has all of the all your like queries and mutations right there for you. So you still can have like a full monolithic app with web, backend, and a mobile app, and without GraphQL or any of that type of stuff.
Okay, so this generated client would essentially be imported in the mobile app and will be used as sort of like the layer to interact with the backend.
Exactly. So just like you do on the web and the code I showed in the talk, that would be the same way with React Native code.
I see. And then we also had another question. Can I call the auto-generated API from the mobile app? And I guess we've just answered that. I mean, you just did.
Yeah. And you can call it from anywhere. It's just a publicly exposed endpoint. And as long as you authenticate it, like you can use the password stuff, get a token, or you can add token authentication where it's like a long-lived API token, like for third-party services.
I see. So something like a JSON web token that you pass along and that essentially gives you. Okay. And let's see if we have any questions coming in. We had a lot of questions on Slack. Is there an option for GraphQL as well? Do you want to take that one?
Yeah. So right now, that auto-generated API is plain JSON, but there's the opportunity to swap that out for GraphQL. So we're happy. It would be great to have that GraphQL layer in there, but with the same like end-to-end experience where you don't have to think about it for most cases, but then it's there if you do want to use it for some reason or for other apps. So that's one way. It might take a lot of work, but I think it's possible. And the other way is that you can use your Blitz queries and mutations as the resolvers for a GraphQL API. So you can add a custom API route, and add Apollo server or Nexus or whatever, and then import the resolvers. And you're still sharing the code, but you do have a GraphQL API too.
So if I understand, basically, a lot of the ergonomics that you're trying to achieve with Blitz.js and the developer experience is to eliminate the need to implement GraphQL. So it's sort of like...
Exactly.
Okay, I see. Yeah. Okay, let's see if we have any more questions coming in. Prisma Day, okay. Okay, if there are no more questions, I think we will wrap it up. And will you also be available in the next 5 to 10 minutes in case questions come in?
Yeah, sure thing.
Okay, well, on that note, I'd like to really thank you, Brandon, both for your work on Blitz.js and for coming and speaking today. And yeah.
Thank you very much. Great to be here. Great to see you all.
All right, Brandon. Well, have a good night. Okay, we're going to take a short break now, and we'll be back at 6:59 Central European Time. I'm sure more of you from the Americas are joining us now. And many of you asked on Slack whether the recordings of the talks will be available. So yes, the answer is yes, and all of the sessions will be uploaded to YouTube. You can expect that in the near future. And by near future, I mean hopefully in the next week or so. And then after the break, we will have our last talk for the day. And we have a very special guest today. We have Matt Billman, who will be joining us for the last talk. So use this time, refresh yourself, and we'll see you after the break. Welcome back. We now come to the last part of Prisma Day. We have a very, very exciting speaker. In the previous part, we looked at Redwood.js and Blitz.js and saw how they provide the tools for the modern web, allowing developers to focus on solving problems they care about. In this part, Matt will take us on a journey looking at how data connects to the Jamstack through platforms and APIs. I'm really honored to have Matt Billman speak today. Matt Billman is the CEO and technical co-founder of Netlify, software company founded in 2014, and today one of the fastest growing web development platforms. He's been building developer tools, content management systems, and web infrastructure for more than a decade, and he's known for coining the term Jamstack. Matt's talk title is The Jamstack and Your Data. So give it up for Matt.
Hi, everybody. Thanks for having me here at Prisma Days. I'll be talking about the Jamstack and your data today. It's a topic that I haven't gone into real depth with before, but I've definitively been giving this a lot of thought and talked a lot about it internally, and it's something that I do think will play a big role in the future of the Jamstack and the web. Just a little brief background on me. I'm Matt Billman. I'm the CEO and co-founder of Netlify. Netlify is the fastest way to build the fastest sites. We've been around for more than 5 years now. We have close to 1 million developers on our platform, and have really built the whole platform around this idea of the Jamstack architecture as a better way to build faster and more scalable websites and web applications. Let me start by just talking a bit about the Jamstack and the fundamentals of this architecture. When we talk about the Jamstack, we're really talking about like the evolution of the web, and not so much about a specific stack of a set of technologies, but more about a philosophy and an architecture. You could say that the stack today has moved up a level. If we look sort of way back in the early days of the pre-web, we had this very clear Unix model with a client and a server. Then during the whole period of sort of the Web 2.0 and a lot of the discovery of e-commerce and social networks and all of that, we sort of built this whole dynamic database-driven web application where you would have a client, in this case the browser, that would talk to a web server, sometimes through a load balancer and a layer of caches and so on. And then we would have an application server that would talk to a database that would give back data. We would like use that data to take templates and assemble back HTML that we could send back to the browser. And that way we could build like advanced functionalities like form handling or e-commerce or search or so on and so on. And then by now we've sort of really shifted to a modern web model where we're expecting like to have this kind of pre-built front end that lives directly on a global content delivery network or an application delivery network, where the browser will like very instantly fetch the front end and then talk no longer to one server, but to all these different services. If we take another look at sort of the architecture and the difference between the Jamstack architecture and the monolithic architecture, it's no coincidence that the Jamstack doesn't really, in its name, like it's JavaScript API and markup, but it's no longer the name of a specific web server or a specific database or a specific programming language. It's more this sense that the stack has moved up a level. And today, as developers, we build for the edge for code that runs directly in the browser and talks to all these different APIs. Now, what we saw an opportunity to do at Netlify when we launched was really to go in and say, like, okay, so when you're building in this way, when you take this approach, there's all these different set of tools that starts becoming a part of building for this stack. You obviously need to develop locally. You need like to build and test. When you have this concept of like delivering a pre-built front end directly from a CDN, you always get this CI/CD pipeline. You get this deployment step where you want to be able to guarantee atomic deploys with instant cache invalidation, where you don't have to worry if different parts of the site are out of sync with each other. You obviously have a hosting component where you do need that end result to live somewhere. We've started to see serverless function play a really important role in this whole world. And obviously you want that final end result to live directly on a global delivery network. So what we saw an opportunity to do with Netlify early on was say like, okay, there should be like one single seamless workflow where you can develop, build and test, deploy, host, work with serverless functions, have the edge handlers included and so on. And developers shouldn't have to think about all these different vendors stitching together all of these different tools. It should be enough to just work locally, push to Git, and then know that the rest just flows naturally from there. Now, if we look back at sort of the traditional server rendered web we had in that middle step in the diagram before, we had this concept of like a browser sending a request to a server, and then a lot of work would be done on the server. We would build the templates, talk to the database, all of this to be able to like make sure that every page view had its unique representation and so on. And from the world of that, we sort of entered into the world of this concept of single page applications where we say, okay, all the server does is basically just deliver a little bit of HTML, and then all the rest of the work can be done by the browser, right? Like this is how app.netlify.com is built, for example. It's a typical like traditional single page application where all the rendering happens in the browser. The browser will talk to our API and to a couple of other APIs like GitHub's APIs and GitLab's API and to a couple of serverless functions and so on, right? But all the server does in that case is just gives you a really small app shell that the browser can spin up and operate from. Really similar to what you would imagine from like a mobile application or something like that, right? You basically just have an application, a client that talks to these different services, and there's not really like when you do move around in the UI, there's no involvement from the server in that way. Now, when we talk about the Jamstack, there's sometimes this misconception that the Jamstack is just about like static site generation or something like that. And it's not so much like that. That's not the core of it. The core of it is taking this approach where at runtime, the server does almost no work. The server is typically just a CDN edge node that just delivers you your HTML, your CSS, your JavaScript, and delegates the rest to the browser. But we start really taking serious this whole build step where before that happens, we can pre-build a lot of the different sites, a lot of the interaction. We can generate as much HTML upfront, and we can communicate with APIs. We could do a lot of the heavy lifting at that step. So the work done by the browser becomes much smaller as well. And that's the way we get the ideal world of the best performance and the best end user experience. And if we look sort of after that build step, right? Like once we have the build, we'll distribute the front end to all these different edge nodes. There'll typically still be some kind of runtime outside of the browser, right? Like the JavaScript layer will talk to sometimes different cloud functions, sometimes different APIs and services. And if we look at these APIs, we might sometimes talk to the APIs directly from the browser. And sometimes we'll have serverless functions that serves as an intermediary and talk to the APIs on the user's behalf. A really classical example would be something like using Stripe, where Stripe as an API both offer a bunch of widgets that you can pull in directly from the client side when you do the actual credit card input and so on. That all happens client side. You don't need any backend for it. But then the moment you actually want to execute a payment, make a charge against the credit card, you need some server somewhere that has the secret API token for Stripe that can actually do that final transaction and send it back, right? And that's one of these things where before this sort of whole Jamstack approach or before the serverless functions got introduced into this world, we would always get to this point where like as a developer, I actually had now to think about having a server somewhere running. I had to think about my server, even if it was just for that little interaction. I had to think about like, where is it? What kind of server is it? Is the software on the server up to date? Do I have monitoring on the server? Do I know if it will be around? Do I know how many times it restarts? What happens when it restarts? Do I need 2 servers so I can load balance and restart them one at a time, and so on and so on? And that whole API layer now has gone from like a couple of them to a very broad ecosystem that's all available to us as developers whenever we want to build sites or applications with this approach. Services like Contentful or Snipcart, tools like Gatsby or Data CMS or the like. And if we think about sort of an approach to a modern application and how we would architect it and build it, if we think about like a typical e-commerce application, for example, we might have that build layer where I said like we try to push as much of the work we can in there. We might try to pre-build as much of all of the different product pages we can by talking to a bunch of different APIs, right? We might talk to our main content API. We might get inventory and sizes and customer ratings and prices and related items from different services at the build time before anything happens in the browser. And then on the other hand, once the user is in front of the site, we might do things like personalization, advanced search, or the actual e-commerce functionality of buying an item or going through the checkout by having like our front end talk to different APIs and services. And if we go back here and look at this old diagram around the evolution of the web and how it happened, right? Like one of the things that's interesting is that when we look at the legacy web, the database is like a big part of it, right? We have this concept of my database. The first place I learned to build dynamic web applications back in the day was from the tutorials at MySQL's website around database-driven websites, right? It was really this concept of like, I have my website and I have my database. When we look at this modern web diagram, there's no database mentioned. So what does that mean? Well, if we go back to our fictitious e-commerce app, we might think like, okay, maybe at build time, we're talking to Contentful and we're pulling in products and prices from Shopify. We might use a couple of other services. Maybe when you go to the app, we might be using Auth0 for login and authentication. We might do all the fancy search elements through Algolia. Who knows, maybe we have like some application-specific data in FaunaDB that sort of glues together a couple of the different services and keep tracks of how they're related. And when we think about it, like obviously each of those very much have a database, maybe multiple databases, right? Like Contentful definitively feels like a database. We stuff things in there and get things out of it. Shopify has our whole product database. Auth0 has our user database with all our user data. Algolia is a very optimized search database. Fauna is a globally distributed NoSQL database that we can talk to. So it's not that we've gotten rid of the database, but it's that we've gotten rid of the concept of my database, and instead we have all these different sources of data. And you think about this old world of my app and my database, then the new world looks more just like my UI, my front end. Maybe we even have different front ends. Maybe we have mobile applications as well. Maybe we have kiosks and an actual store. And then my data, like we no longer think about my database, right? You don't talk about Contentful or Stripe as my database for orders or for content. Don't talk about Auth0 as my database for users. But you do think about my data, right? Like here's my user data, here's my content, here's my orders, here's my e-commerce. So in the old world, not only would we have my database, right? But you would also have like my server that's currently the primary. You would have like your secondary, you would have the backups, right? And we would think carefully about like, oh, what's the instance size I'm currently running this data on? What's the disk size? How much can I stuff into this database? Do I need sets, replica sets? What do I need to do to scale? Can I scale horizontally or vertically? All of these things. You talk about provisioning and so on. On the other hand, when I add Auth0 to my website to authenticate users, I just expect it to be there, right? Like I don't expect to worry about any of those concerns, like where do they get stored? How is the replication working? How do I scale it? When I activate Algolia, I just start sending data into the index, and then I just expect to be able to query it. But I don't worry about instance sizes or disk sizes for my index. And the same with a contentful. I set up a space for my content, and I just expect my editors to be able to work there. And I don't have to worry about any of the physical details around that data. And we're even starting to see like general purpose databases that acts and feels in this way. When I start using a FaunaDB distribution from their cloud product, I don't start thinking about like which regions is it distributed in, how is the clustering working, what's about the replication. I just sort of churn on a database and start expecting there to be data. So in a similar way where if we had the legacy step with the client, the web server, and the app server, just that code layer, and we had that sort of monolithic application that would live on the app server, then whenever we did something there, we had to think about that app server, right? Like back in the day, like you would have your server and you would like log into your server with SSH and keep track of it and update it. You would provision servers. You would worry about like the load balance and thing. You would think like, oh, do I need some form of auto scaling if a lot of people come to my app servers at the same time? How do I manage that? What about monitoring? Like I need to know if my server is actually running or if it's disappeared or if it's restarting or if it needs to be updated. I need to manage Linux updates and system updates of all my packages. I need to make sure, like, I need to even consider what kind of OS, like, do I want to run Ubuntu or Debian and so on my server? And once we sort of transition to the Jamstack, we have this pre-built client directly out of an edge network, and then a lot of the code that's not like just in APIs, we'll just write in serverless functions, right? And instead of like this monolithic application, we just write our functions. And then we just expect them to run. We don't expect any operations. We don't expect to worry about like what's the instance type of my functions, how is the auto scaling working? Do I need to actually check if they are up or down or if they're getting restarted? We've sort of accepted that that's just a service that takes care of that. We just write the code and then expect it to run. And one of the things that I think will happen with data when we talk about the Jamstack is that developers will start having the same kind of expectation, that we'll start imagining data functioning in the same way. In the old world, we would always think about like database provisioning, and this is still a world like most of us are definitively still there. We'll think about database provisioning, we'll think about replication, instance sizes. How much do they cost? How do we scale them? How many do we need? We'll think about which regions our data should live in and be like, do we make sure we do cross-region replication for safety? We'll very much, like anyone that's ever run a database has probably run out of disk space sometime. I know I have. We'll think about backups, and hopefully we'll think really carefully about it because it's like essential to recovering from errors. And I feel like once we really start applying the same kind of approach that we're seeing around the rest of the whole infrastructure, where we basically just write our code, we push to Git, and then we expect everything to just happen from there. We'll also move to a world where developers will just expect like, okay, I have some kind of bucket, just write data and query data, and that's it. I don't have to worry about the rest. That's exactly what's already in some ways happening as we start delegating to these different services, right? Like as soon as you activate a contentful space, you don't think about provisioning or backups or replication or regions. You just expect it to be there, and now you can write to it and read from it. when you set up Auth0, you just think, okay, now I can start having users sign up or delete themselves, and I can query users and they're just there. And I don't have to worry about the data. So in some way, we are moving towards this general concept of our data being no longer in one specific database. I no longer have my database, just have my data, and it's distributed across all these different services. And we're starting to see these generic databases emerge that works in the same way, where FaunaDB or Firebase just feels like, okay, I turn it on, I start putting in data, and I start getting out data, and I'm no longer concerned about the operations around it. So I think as we move further and further into the world of the data, we're starting to of the Jamstack, we're starting to think of our data layer in that sense of just this distributed layer of services that exists around different properties, and that I, as a developer, no longer have to worry about as the underlying abstractions of. Now, of course, one of the things that happens there is also certain fragmentation. Now my user data might live in one service. My content might live in a different service by a completely different provider. Now my products might be over in a Shopify and completely different provider again. My subscriptions might be located with Stripe in a different provider in a different place. My permissions might be in my own database managed by a different provider and running in a different place, and so on and so on. So in one of the last thoughts I'll leave you with in this talk, it's not so much a specific prediction or specific insight on where we are now or how to do things, but more about what will happen next. And I think there'll be some sense of like, and I have here in this chart sort of a set of disparaged logos that are not necessarily strictly related in any way, but it's an interesting area to look at. Like once we have all of these different services that persist our data and that we write to and read from, how do we actually start getting some unified way of thinking about it and querying about it? How can we have systems that abstracts, just like Netlify has done, from the whole process of writing code to having it run on an edge network through build processes and continued deployment processes and atomic deploys and hosting of serverless functions and so on. Well, we start seeing some similar layers, like TakeShape are working on the idea of a content mesh like that allows you to tie together services like Contentful and Shopify and have like one unified GraphQL API to access them both, and where you can write and read from both as if they were one thing. A service like OneGraph is trying to sort of do that across all this landscape of APIs and provide like live subscriptions through GraphQL across different APIs, allowing joins and complex complex operations. Apollo has obviously been in the space of GraphQL for a while and have like often this concept of an enterprise having their whole internal graph of all their services and API exposed as one unit that the front-end web developers can sort of just build around. And of course, Prisma is sort of defining this new generation of query layers and ways to think about data in a way that's more agnostic to the specific databases and closer to the way we work at the code level. So I imagine that over time we'll see products that go more and more in this direction of saying, like, once we fully adopted this Jamstack approach, where we have a front end that lives directly on the edge, that has a big build step and so on, and where we no longer have our app server and our application, but just like our front end and all these different APIs and services, and where we no longer have our database, but just our data. How do we start gluing that data together, and how do we get a more unifying way of working with it as developers? And how do we get like to a point where we don't necessarily feel the weight of all the underlying vendors as much as we do today? I'll leave you on that thought. Thank you so much for having me. There'll be a short QA session, and I'm happy to chat about this with any of you. It's an area I'm really interested to also hear your all thoughts around. Thank you.
Thank you, Matt. I really enjoyed your talk. I think it's really fascinating to just see how like the landscape of Jamstack just emerged with APIs covering almost every aspect of the application development process.
Absolutely.
So I think you sort of like, you really, in the end, you gave a glimpse into what we may see in the future with the unifying the query layers. And I think that really opens up, it's a good opening for the Q&A. Are you ready to take some questions?
Absolutely, happy to.
Okay, so I think one of the questions that I'm personally also very interested in is, what do you look forward to the most in the current web ecosystem?
What do we look forward to the most? I mean, I think this is a really interesting time. Like we just saw 2 frameworks talks. I'm very excited about what Tom is doing with Redwood. I'm very excited about how this whole tooling emerges now that, like, for a long time, it was sort of more of a question, is this approach going to be interesting to people? Is this going to be right? And so on, right? And now we have like I think a pretty big sort of drive behind this concept, that this idea of separating the front end into its own thing, to really having a workflow around it, to do global distribution, to consume APIs, to work with all these services, that sort of really become mainstream and driving, right? So now it's really fascinating just to see all the development in the tooling experience around it. How can we make it easier to get started? How can we make it easier to tie things together? How can we, the whole API ecosystem that in many ways emerged out of the world of mobile development, right? Like, I think that was like sort of a trigger point for the make an API for everything. I think now it's really starting to also move towards the web and see like Jamstack apps as primary consumers for their APIs and see their role in that, right? So seeing that whole ecosystem evolve from frameworks to APIs to services like ours that can glue things together and make the whole process easier for developers and make the development experience better is really fascinating.
Yeah, absolutely. So, I mean, Netlify having played a major role in that, what can we expect from Netlify in the near future?
Yeah, I mean, some of the things we just showed around like at the Jamstack conference for the industry. We just launched this new feature called build plugins, which is part of what I think we'll see in general, right? Like, so when we built Netlify, one of the core insights we had was that once you really became opinionated around this Jamstack architecture and said, like, we're going to decouple the front end and the back end, we're always going to have a build step, we're going to have this idea of atomic deploys to a globally distributed network, then there was just like this whole part, like this whole set of services that we could provide sort of one solution for, where you just write your code and then that solution will work for you and do all the works of traditional operations and infrastructure companies and so on, right? And the next step we saw there that made us launch build plugins was really just that within that build step that you now have for every single application, of course, there's like a whole set of things you will do there that's not necessarily specific to your application, right? Like, so accessibility testing or integrating into bug trackers like Sentry or running end-to-end test with Cypress. So all of these things are like not necessarily parts of a build chain that's unique to one website or one web application or one project or one developer, right? Like they're sort of more cross-cutting concerns. So why should every development team have to like integrate them and build them on their own, right? So that was one of the ideas with build plugins, right? Like, how can we take the things that are common for people and just make them ideally one-click installable, maybe one-click install in some configuration in some cases, right? And then programmable if you want to do more advanced stuff, right? But just this concept that in this layer, there are building blocks that we can generalize and say, like, this is just how it's done when you want to solve this problem. So,
Right,
so that's
yeah.
one area we're pretty excited about evolving, and where there's still a whole roadmap ahead of us, of course, right?
Yeah.
Another thing we just gave an initial preview of that's still just in private beta is our edge handlers, which I think is another really interesting architectural component that I think we'll see play a big role also in the future, especially for really large projects, right? So one thing we saw very early on at Netlify was that part of the idea around this kind of Jamstack architecture was to completely get rid of this traditional idea of your web server, right? Like your central server with your database and so on, right? And we built this distributed network where you push your front end, right? And then it just lives on servers all over the world instead of on your central web server, right? But right from the beginning, we saw that then we had to also build solutions for a lot of the things that you would typically do in your web server, right? Like redirects, proxying, geolocalization, localization, all of these things, right? So we built like a very flexible and rules engine, right? But like a declarative engine that could do these things for you, right? And edge handlers is basically taking that whole edge layer and making it fully programmable to developers in the same kind of easy workflow as the rest of the system, right? So that opens up for doing a lot of interesting things around personalization or authentication or transforms of what you're delivering. You can imagine building experimentation frameworks at that layer and all of these things that you want to execute really close to the user. Like there's always this difference. There's code you want to execute really close to your data, and then there's code you want to execute really close to your user, right? And this allows people to also take full control of that code that runs really close to the user. And I'm quite excited about the possibilities there. At first, just opening it up to be fully programmable, right? And then in the same way as with build plugins, in certain ways see like, okay, so what are the common use cases that people are building over and over again, and how can we make those really easy?
Right. Yeah, it sounds exciting. So this is currently in beta status. Is that correct?
Yeah, it's currently private beta.
Okay. We also had, it was a really interesting distinction you made there between things that you want close to your users and things that you want close to your data. And sort of building on that, we had a question come in that I think really relates to that. So I'll just read it out. So it's awesome that we can use services like Auth0, Contentful, and Shopify to cover most of the stateful part of our projects. But sometimes you just need to have a custom database. It feels like none of the existing databases have really nailed the developer experience we expect for doing Jamstack development. What would your dream database for Jamstack development look like?
Yeah, it's a great comment, and I gave one answer in Slack, and I'll talk a little to it, right? Like I think it's spot on that we're at this stage where none of the current databases are like the obvious choice, right? Like the world of traditional databases have like this disconnect with how we think about like functions and the rest of our code, right? Like they're still very based on this idea of like running a database with a certain number of servers and replication modes and failover modes and provisioning and migrations and so on, that just has such a different feel than this whole world of like, I write code, I push it and it runs, right? I think the ones that are coming closest are obviously like tools like DynamoDB, especially in like the global replication mode at Amazon. FaunaDB is sort of has a lot of the right characteristics in terms of being globally distributed, just like you just turn it on, it's fully multi-tenant. There's no provisioning step. Firebase has been one of sort of the early examples of that kind of feel where you just turn on data and you start talking to it. But I think there's still a lot of work around like the full end-to-end experience of working with those databases, right? Like how do you reliably manage your data in them? How do you integrate them into other systems if they're not like traditional SQL interfaces? Like how do you like do you need to learn a new query language for each of them, or can they find some common ground, right? I think obviously Prisma is an interesting layer in that whole discussion. And then there's the other question of like, how do we, like, another question is, as we also get used to with our whole front end and our functions and everything, to have this very easy idea of like spinning up a branch and just having like the branch base built be our staging environment and so on, right? Like, what's the corresponding thing with our data, right? Like, because again, once you then start having like one database for production, another one for staging, and like, then you're still back to something that feels a bit more like this world of like your servers that you have to manage, like set up, tear down, like all of those steps, right? So I think the ideal database will be having a familiar query language that doesn't feel like super unique, and that feels quite native to the world of JavaScript and JavaScript objects and so on. It will be globally distributed. It will be multi-tenant and always on. And it will have easy ways to spin off like essentially branches or forks and talk to those in isolation.
Well, I look forward to that. If we have a moment, I think there's also a couple more interesting questions that came in. Let me just see. Yeah, so with the drive towards leveraging so many services, what are your thoughts around security and data ownership?
Yeah, that's a really interesting question as well, right? And there's no simple answer to it, right? Like, I think in part we are seeing just in general the public and governments, like both in Europe and California and so on, put much clearer rules in place in terms of what's expected from companies that deal with data, right? And I don't necessarily think that like, for example, I will tend to assume that companies like Okta or Auth0 are really good at dealing with the security and privacy around user data, compared to most like companies that just build their own data infrastructure and run it themselves and so on, right? Like, I would assume that the really specialized services get quite good at privacy, at data security and so on, and that they have more dedicated security teams than most normal development teams would have, right? So in that way, I think there can be actually real improvements, right? And then on the other hand, of course, like, as soon as you have like more of this model of like just turn it on and put data there and take it out again, it can also easily lead to a more like sort of laissez-faire approach to thinking about data, right? And maybe not considering as strictly way you put it. So I don't think there's a simple answer, but I do think I think there's sort of two movements. One is just like the stronger regulation around it and holding companies to higher standards, right? Then there is another interesting like path in that space that's more about like the idea of self-owned data, right? And sort of using technologies more tied to the ideas of blockchains to let users encrypt and own their data themselves, or having data that's essentially encoded with the use with some sort of private key and so on, right? Like Userbase is an interesting example in that space that are sort of working on like, hey, how can we make sure that we as a company can't even access the data? I think we're still.
Can you repeat the name of that company? Sorry, I missed that.
Userbase.
Okay.
Yeah, it's a small startup, but just an interesting one in that space, right? And I think there's a lot of experimentation and research being done there, right? Like, the hard part is that in general, once these privacy concerns ends up influencing the user experience, it's very hard to get them to win over user experience, right? Like,
yeah. Okay. Well, Matt, Thank you so much for your talk and for a lot of the very insightful comments that you made, both in the talk and the Q&A. It's been a pleasure having you.
Thanks for having me.
All right. Well, have a good day. Okay, so we now come towards the end of Prisma Day. We have some closing remarks. Before we wrap up Prisma Day, I'd like to talk a bit about the Prisma roadmap. Today I was sitting with the product team and we spoke a little bit about some of the themes that we have in the roadmap. And essentially we have two main themes that we are going to be focusing on. And you can expect that a lot of the issues would be associated with one of those two themes. So the first is strengthening querying capabilities. And by that, we mean things like aggregate functions, like things like doing group by, doing things like distinct, and also doing things like DB, database string functions, like doing like a lowercase function on a query. So that is the one thing that we have, strengthening the query capability so that you can do more with the Prisma API, essentially, rather than having to type a raw SQL in the case of relational databases. And then the second theme we have is opening up to new communities. And there are two fronts that we can do that on. The one is having more generated clients. I think it may have been covered today, but Prisma is actually built around a Prisma engine, which is written in Rust, and a very lightweight layer, which is the client layer. So if to those of you who've used the Prisma TypeScript client, it's actually a very lightweight layer. And that means that we can also build a lot more clients for other languages. So for example, we already have a Go client, which is being worked on. So that was one end of opening up to new communities. And then the other sort of side of it is also having extended support for more databases. And on that front, we have some work being done on Microsoft SQL server. And the reason that I mentioned sort of these in the context of themes is because it's very difficult to give strict and accurate timelines for these things. And that's why we sort of really try to do it in a gradual process, and we're involving the community in this process. So all of these things are happening out in the open and you can participate in the discussions. We're also really interested to hear more of your input. And then besides that, obviously, we're working on Prisma Migrate, and we obviously heard from a lot of you today and how important that is. And that is something that we have on our roadmap. And then on the sort of more immediate term, we have things like reintrospection. So this whole process of introspecting your database multiple times as you apply changes to the database and then maintaining the changes. So that is something that is being worked on immediately. And then dynamic data sources and many more. So I'll end the sort of remarks regarding the Prisma roadmap. And so we're coming to an end. And I'd really, really like to thank all of you for joining today from all the different countries. Really, I think we've had people joining from all corners of the globe. So it's really wonderful to see how we're breaking these geographical barriers and we're bringing all of you together. And how like the internet and the technology that we're all building is facilitating that. I'd also like to thank all the speakers who've really worked hard to prepare their talks and to overcome some of the technical challenges in making this conference online. Some of you may have been with us last year during Prisma Day, which took place in Berlin. And I think 2020 is really the year that we're learning to shift towards an online format. So it's a learning process, I think, for all the industry. And I think that we're learning how to make these experiences more engaging and involving communities and really breaking those geographical barriers. If you've joined more recently today, I'd like to mention that we've also launched today the Prisma Data Guide. It's an online, constantly expanding resource of tutorials and articles on databases. There's a lot of articles on how to choose databases, how to use them in your application, and understand how they work under the hood. In the coming future, we'll also be doing a lot more workshops and live streams covering many aspects of modern application development as we did today, and also covering many aspects of Prisma, new features, and also new integrations, and showcasing some of the ways that you can actually run Prisma in production. We're really interested to hear more from you. As I've said before, this is a community-focused event, and we're very interested to hear the kind of things that you're building with Prisma. So if you haven't already, we have a showcase channel on the Slack, and we'd be really interested to hear more about the kind of things that you're building. So that is it for Prisma Day. Thank you so much for joining today, and have a nice evening, day, or morning, depending on where you're joining from.